அட்மினிஸ்ட்ரேட்டரா எத்தனை பேர் இருக்கான்னு பார்த்தேன். 6 பேர் மீட் பண்ணிடுறேன் சார்.
లైవ్ చేస్తా.
మీరు హెడ్ ఫోన్స్ ఏం పెట్టలేదు కదా సిస్టమ్?
పెట్టలేదు.
Dr. O'Neill Joseph. Dr. O'Neill Joseph. Dr. O'Neill Joseph.
Yeah, good afternoon, sir. Good afternoon.
Good afternoon. How are you?
Yeah, fine. Long time. I remember the good time we had in Switcher when
Yes,
we
yes,
visited
yes.
you. Yeah.
This time also, you were not there, no? In EC committee.
Yeah, because the maximum time is 8 years continuously, sir. So I completed 8 years. So
Okay.
my time is over. I have to take a break from the National AC. All the best for you for the next 2 years.
Thank you. It is first time only that I got elected.
Yeah.
Okay.
So how is things going, sir?
Things going okay, but this lockdown, no, confined to home, these 4 walls, within the 4 walls confined.
Ravi is the chair of the session. Ravi will be joining soon, I think.
Ravi
is the session coordinator. Ravi Kiran.
Acha. So he has. Yeah. I think he will initiate, no? Then we will start.
Yeah. He will have to introduce us, and then you have to introduce him. Then we will start.
Okay. Okay, then we will mute and then wait for
we will wait for this thing. Yeah.
Okay. Thank you.
Professor Day?
Yeah. Good afternoon, Ravi. I am here.
Yeah, I was looking to your CV because I have to introduce you.
No problem. No need.
Okay.
No need. Just tell Professor NIT teacher. That's all.
So I'll introduce you directly, whatever information I have. I was trying to reach your mobile number actually, but
where is mobile?
And Anil, your mobile is also switched off.
My mobile.
Oh, I think I am out of charge. 1 second. I am out of charge. Just now only I saw that. Okay.
So good afternoon, and I think we have. So let's. We have 15 papers in this theme, huh?
Yes, 15 papers in this session. Yeah.
And we have around 1.5 hours. So
6 minutes.
90. So 5 minutes if I consider 1 minute for logging in, logging out. So
Yeah.
a bit tight. So I think we need to maintain the time schedules. Otherwise,
Yeah, it will happen like yesterday. Yeah. I think Ravi, the first two presenters are already there, so you can start, I believe.
we can start. I think it's already 2 p.m.
Yeah, we'll be on time.
Yeah. So good afternoon, all the delegates and presenters. This is Ravi Kiran Vaidya here from Geodynamics and IGS National Executive Committee member. For this session, which is on deep foundations, I think we have a variety of papers from a variety of students from a variety of backgrounds and presenters from a variety of backgrounds. As we all know, with the increased focus on infrastructure and land being scarce, deep foundations in urban areas has gained significant importance. So if you look now, you look at Mumbai, Delhi, or Cochin, even Cochin, we have double basements, we have triple basements. So we have deep excavations, we have diaphragm walls, we have retaining walls, soil nailing, soil anchors, all these things become a part of deep excavations. Similarly, if I look at pile foundations, you have diameters which are ranging from say 300 mm to 2.5 or even 3.5 meter diameter piles. And these days, even the capacity on the piles is increasing. So if I talk of a 300 mm diameter micro pile, then you might see something like 100 tons of design load. It's not unusual in rock-socketed and rock-socketed piles. Similarly, you have rock anchors, soil anchors. So there's a huge amount of technology change which is happening in terms of design, in terms of construction, and in terms of testing. And actually, these kind of deep foundation sessions would merit an entire day of discussion with a variety of topics and a give and take and exchange of information. So we are happy to have 15 papers in this session. We have some senior members, Mr. Ravi Sundaram and others also joining in. Good afternoon, sir, and welcome to the session. Now I'll introduce you to our chairman of the session is Professor Ashim Kanti De. So Ashim Kanti De is a professor at NIT Silchar, and his area of interest is soil structure interaction and deep foundations. He has done a lot of work in the northeastern region, which is one of the remote places, and I'm sure problems like landslides and other issues also he must be handling. So I welcome Ashim Kanti De as the chairman of the session. And I hope to hear his views and his ideas through the course of the discussions. Our co-chairman is Dr. Anil Joseph. As I said yesterday, Anil Joseph wears a variety of hats. He is a geotechnical engineer, he is a structural engineer, he is expert in laboratory and soil investigation and deep foundation piling. So he did his master's from NIT and his PhD from NIT Calicut. He is the director in geostructurals, which is his company, and he is also the director and engineering diagnostics.
Volume will change.
He has received several awards for structural design works. Important areas from the airport to his office, and you will see the Toyota building with a variety of equipment for which he has been National Executive Committee. He has just retired as a National Executive Committee member of the IGS.
Can you ask the help of administrator to mute mics are not on, otherwise your voice is not.
Yeah. So Anil Joseph is a National Executive Committee member of the IGS, just retired, and he's on the TC 220 committee. He is on a variety of bodies as a chairman or president or secretary. For example, I can state some of them is like Structural and Association of Structural and Geotechnical Consultants, Association of Piling Specialists, Executive Committee member of the Builders Association of India Cochin chapter, member of the Association of Contracting Engineers, and an adjunct faculty at the Albertian Institute of Science and Technology. So I welcome Anil Joseph as the co-chairman for the session, and I hand over the session to Professor Day and Dr. Anil Joseph to get started from here. Thank you, sir.
Thank you, Dr. Robi, for very good and elaborate introduction. Thank you very much. I welcome Anil Joseph also in this session. Actually, we have 15 presentators as per the list given to us, and we have 90 minutes, and so we should be very strict. I think 6 minutes then per presentator, and after 5 minutes, I think we will give a just a ring, and then by 6 minutes we have to say kindly stop or not, Joseph. Joseph. So after 6 minutes, we have to say kindly stop. Okay. Then Joseph, I think you can start.
Dr. Day, I have a small request.
Sir, please, sir.
This is Ravi Sundaram. Since I am chairing another session parallelly here, so I would appreciate if you can allow me to make my presentation first, so that I can then go to the other session.
I think that's something
you can have 6 minutes. Okay.
Yes,
Right.
sir, definitely. You can.
Okay, sir.
Yes. Thank you.
Kindly,
Sir, before Ravi Sundaran sir, good afternoon, Ravi Sundaran sir. Before Ravi Sundaran sir take over, let me have the privilege to introduce the session chair, Ravi Kiran Vaidya. So the principal engineer of Geodynamics has been instrumental in popularizing the concept of deep foundation testing in India. He has created a deep foundation testing industry today. Geodynamics is India's biggest and well-accomplished company in this field. Pioneering methods like high-strain dynamic testing, integrity testing, sonic logging, etc. for pile foundation in India has been his contribution to 2 decades ago. His work has resulted in various sectors in the methods being accepted by all bodies, including metro, highway, railway, and most bodies. Jointly with Dr. Jaikumar Shukla, he has also introduced and successfully demonstrated bidirectional load testing for large capacity piles. He has worked on almost all the prestigious projects in the country. Anywhere you travel in the country, Geodynamics and Ravi Kiran is known for the testings and all the other connected industry. And he has also worked in 20 different countries worldwide, including Southeast Asia, Africa, Middle East, and the Gulf. In addition to this, he has written various technical papers on the subject, and he is an authorized trainer for these technologies worldwide. Yesterday, he has been awarded with the prestigious Dinesh Mohan Award for the excellence in professional practice in geotechnical engineering for the year 2018-19 by the IGS. He is a National Executive Committee member of IGS and a close friend of mine, also into IRS and BAS, and he is a master's in structural engineering from MS University of Baroda. In addition to this, he is a half marathon runner and a national table tennis player. So a very dynamic, geodynamic personality. Ravi Kiran Vaidya will be the session chair. Now, over to our dynamic Ravi Sundaran sir for your topic number, sir.
TH33. TH33.
Yeah, TH33.
Sorry, just one liner before, I mean, not for you, but for some of the new students who are presenting for the first time or second time. You have 6 minutes of time, and my advice would be very crisp. What is your aim or objective? What broadly you have done? What was one slide on literature survey, and what were your findings, and what you intend to do? So, even like 7, 8, 10 slides should crisply give what was your aim and goal. Don't go into the equations and the theoretical part of it. Otherwise, you'll be short of time.
Yeah, that's a good guideline, Ravi. And now the topic of the presentation, Western Rajasthan. And over to you, Ravi Sundaran sir. And we are all ears to hear from
Can you see my screen?
Not yet.
you. It's coming up, sir. It's coming up.
Can you see that now? So I'm presenting on short piles for a solar power plant in Western Rajasthan. I acknowledge my co-authors from NTPC and Senjas. We have done this work together. So as you know, solar power is an alternative clean energy source. It's a readily available non-polluting source. The Indian government has launched a major thrust in this sector, and it is planned that the energy from alternative sources, the power generation from alternative sources, should equal the thermal power generation. So solar is now a very big thrust here. Rajasthan is blessed with good sunlight and a large number of clear sunny days in the year. So, ideal location for a solar power plant. So, I'm presenting a case study of a solar photovoltaic plant in Jodhpur in Western Rajasthan. The site covers an area of 600 acres. The power generation plant is 300 megawatts. The solar photovoltaic plant has thousands of lightly loaded solar panels. These are usually supported on short piles ranging in length from 1.5 to 3.5 meters. Pull-out and lateral loads are the critical loading condition, usually due to wind. The downward load on the piles is usually very small. Geology and geotechnical investigation here, this area belongs to the Thar Desert, so dune sands are piled up over an irregular rocky floor. It's a wide expanse of wind-blown sand. So this is the geotechnical investigation being done by a mechanized shell and auger rig. And this is rock drilling using a hydraulic rotary core drilling. More than 100 boreholes were drilled to 5 to 7 meter depth to the soil and rock in addition to various other tests. So this is the stratigraphy we found there. You had a top layer of dune sand underlain by sandstone, and the depth to rock varied from 1 to 7 meters. Groundwater is not there. Rajasthan, of course, groundwater is too deep. So these contours of the depth to rock, you can see on the western side, the rock is at 1 meter depth, and the depth to rock increases to 4 meters, and then beyond even there are patches where there are 7 meters deep. So the typical borehole data on the northern side and on the southeastern side, you see the rock being measured shallow depth in the southeastern side. So look at these solar modules. So you have this is a 3D view of the what we call as the module mounting structure (MMS). The reactions at each column, 1.5 to 2.25 tons uplift, 0.8 to 1.5 tons of lateral load, 1 to 1.5 tons of vertical compression load. Very small loads. That's why you have short piles. The column spacing is around 2.5 feet. So the foundation design, depending on the depth of the rock, two designs were made. One was the short piles socketed into the rock, and the other was the piles embedded into the sand. This presentation is limited to piles in sand. Analysis was done as per the IS code using factor of safety of 2. The vertical and pull-out and compression loads, of course, the IS code. But for lateral load analysis, the IS code is not applicable because it does not satisfy the criteria for long pile. So short pile design has been done using the Bronx approach. You'll find this in Tomlinson and various other books. The modulus of subgrade reaction values were taken from IS code. 2911 part 1 section 3. So the piles which were installed at the project site were 350 mm diameter with a 200 mm size channel section embedded in it. So pile length ranged from 2.65 to 3.1 in sand and 1.8 to 2.8 meters in rock. So we had 1.5 lakh piles installed on the project. So about 140 initial load tests, compression, pull-out, and lateral were done, 2.5 times the design load. So this is the various pile lengths and the piles in sand and piles in rock. So because of the large number of piles installed, even a 0.1 meter change in the pile length can impact the project cost substantially. Therefore, the design aspects of these short piles is quite critical. Now, the pull-out test performed, a typical setup of the load test, and you can
Sir,
see
you
here.
have 1 minute, sir. 1 minute.
Right,
Please.
sir, I'm finishing in 1 minute. So you have the piles which could not be taken to failure, and the other piles which were taken to failure. So where the test was not carried out to failure, hyperbolic correlation has been used to extrapolate. So this settlement by load versus settlement, this will be a straight line. You can see quite a good match. So first we matched the tests which were carried out to failure, and then found the error is small, and then used it to extrapolate the results. So this is the extrapolation done. So back calculation of the soil properties was done to calculate the earth pressure coefficient. We found that most of the values are in a narrow band, SPT value, K value increasing with SPT. So with a plus minus 10% range has been proposed, and we have proposed the K values as a function of the N values. So linear interpolation between these numbers. Lateral load test has been done. Again, the similar kind of approach. We found that the coefficient of earth pressure is very conservative. So we back calculated the earth pressure coefficient and found that it is nearly 3 to 4 times the values which are recommended in the IS code. So there is a lot of need to analyze more data to conclusively make a. So this is an effort, ongoing effort by NTPC and Centers to obtain the desired parameters for soft piles, short piles. So this is my conclusion. We lateral loads are and pull-out are the critical. Large number of piles, so small length will change the capacity, and we have proposed a hyperbolic correlation to extrapolate pull-out loads, and also proposed K value as a function of SPT value, and coefficient of horizontal subgrade reaction needs to be updated. So considering the rapid implementation of solar project, new code needs to be developed for short piles. I thank you very much for your kind attention and giving me the time to present.
Ravisundar sir, thank you very much for that very interesting presentation. In fact, there will be a lot of questions there. So if we can finish the other session, and if we have time, I will request you to join back so that we can have ask few questions. Very interesting, 1,50,000 piles done, and a lot of homework and extrapolation theory which is done on the short pile. Thank you very much, sir, for the presentation. Now, may I call upon Pankaj to come up with his presentation on appraisal of innovative pile foundation to resist lateral loads. Thank you very much, sir.
Sir, you have to stop your sharing of the screen.
Ravisundran sir.
Ravi Sundarasam, you have to stop sharing the screen.
Yeah. Right. Pankaj, you can go ahead. You have 5 minutes time, Pankaj.
Yes, sir. Good afternoon, sir. Today I am trying to highlight my work on the appraisal of innovative file foundations to resist the lateral loads. I am from NIT Suratgarh. These are the controls. Since the modern developing countries like India.
The screen is not shared, Pankaj.
Yes, sir. I will try.
So share it. Yeah.
Is it visible, sir?
Yeah, it's coming up. You can go ahead.
In the modern countries like India, the more preference will be given for the infrastructure development with the help of the schemes like Make in India, Digital Indian program, and urban infrastructure development, and etc. And these indirectly uses the high-rise buildings on the onshore structures, and for offshore constructions for utilizing the renewable resources like wind turbines. that has to be considered by taking into the consideration of economy, and these platforms transmit larger loads to the subsoil, and therefore the pile foundations are to be adopted. And in order to adopt these pile foundations, since we have to think of the economy, so we must try of utilizing some innovative pile foundation to resist these lateral loads. And this work is motivated over economic concerns to overcome the large diameter and large length monopiles foundations that are being used generally. The main support behind this work is these kind of trees, which are generally this is the uh, photograph taken at the botanical garden Pondicherry. Since the tree height was about 50 to 70 meters, uh, since it is a coastal area, the hills are very high, because of which in order to resist these loads, these trees have developed some fin kind of structures above the ground level. It means in order to overcome these lateral loads, it would have developed the larger sized fins in below the ground level even. And we continue with this. Finite piles are described as the pile that has four plates welded to the top of the top. It means the pile head of the regular pile at 90 degrees each. And these are the literature review. Pioneer et al. Worked on the series of model tests, in which he concluded that the pile foundations can be approximately reduced by 15% when compared to the regular pile when we provide with the fins at the pile head. And Peng et al. He studied on the response of the finite piles for both static and cyclic loading conditions by both experimental and finite element method analysis. In the static load test, he worked to assess the effect of different fin dimensions, fin positions, and lateral loading conditions. And whereas for cyclic loading conditions, loading sequences and frequencies, magnitudes are varied, out of which the optimum fin dimensions were finalized. Optimum fin dimensions and fin positions and lateral loading conditions are finalized. And Ahmad Nazar, he tried to.
Pankaj, you can skip the literature, but otherwise we will run short of time.
Sir, actually, this is a literature review paper, sir. It has only six slides.
Fine.
Yes. And in this study, Ahmad Nazar tried to analyze the effect of the relative densities over the lateral load carrying capacity of the pile, and also conducted some parametric study by varying the length, width, and shape of the fins. And after that, he finalized after the testing, he finalized the optimum fin length of the finite pile was about 0.4 times the pile length. And Babu et al. In the year 2018 tried to analyze the lateral load carrying capacity of the finite pile with the help of the Abacus software. And this analysis were performed for the three relative densities over regular piles and the fin piles with 4 and 8 fins. And also the influence of the sand relative density, fin orientation, and their positions were highlighted. The analysis and the interpretation of the results shown that the fins placed near the top portion of the pile carry more lateral loads. And Al-Wazuda, he tried to work on the finite pile groups, in which he tried to check the effects of the pile group patterns and spacing ratios. Spacing ratio means the spacing between the piles. And results highlighted that the increase in the spacing ratio of the pile groups of same pattern led to the increase in the lateral load carrying capacity by 26% and 39% for G4 pattern and G5 pattern respectively. G4 pattern is and G5 pattern are as shown in the figure 2. The maximum gain in the lateral load carrying capacity of the single pile and pile groups were observed to be 76% and 81%. From this, it can be concluded that for regular piles, generally with the increase in the number of piles, the efficiency will decrease. But if you provide with the finite pile groups, the efficiency of the finite pile group increase. And Bhartier studied on the number of fin forming wings, like two fin and four fin, out of which four fin pile carried maximum load, and also tried to study the effect of the fin positions, that is for three fin positions all along the length of pile, that is top fin position, middle length, and bottom width.
Pankaj, you have 1 minute, please.
Yes, sir.
Please.
This is the effect of fin position. He studied for regular pile. This A figure shows for regular pile. B is for the rectangular pile at the top fin position. This is the mid length position, and this is the bottom fin position. And the PY curve shows that the top fin position always carry the maximum load. This blue line shows the piles embedded in the relative density of higher relative density, and red shows the relative density of lower. From these figures, it can be observed that the maximum resistance is provided when the fins are provided at the pile head positions. And the second one is the effect of fin shape and aspect ratio. Fin shapes, generally he considered rectangular fin and triangular fin, out of which also studied the aspect ratio. Rectangular fin was studied for the fin length of 0.25 LP, and for triangular fin he considered for two lengths. One is 0.25 times the length of the length of the pile, and 0.5 times the length of the pile. It means this 0.5 times the length of the pile triangular fin has the same area as that of the rectangular pile. Indirectly from the figure it can be seen that these surface area of the fin for the rectangular and surface area of the fin for the second type of the triangular fin are the same, and also there was some marginal decrease in the lateral resistance for the fin, triangular fin. With this, we can conclude that the fin shape is not only a factor, also the provision of the zone in which the fin are provided is also important. From this, it can be these are the interpretation of the outcomes. The ultimate lateral loads are considered for the 10 times the diameter of the pile, and also the results of the monopile can be used as the reference.
Pankaj,
Okay,
please.
thank you. Thank you very much, Pankaj. A very interesting presentation. We will have the questions towards the last. Now, may I call upon Maurya for the unsatisfactory behavior of board casting safety piles during testing, ignorance or negligence. Over to Maurya.
Thank you, sir. Good afternoon and namaste. Sir, whether my screen is visible?
No, not yet.
Not yet.
Yes, it is getting now.
Yeah.
Yeah, good afternoon. Good afternoon, Mr. Ravikiran Vaidya. This is in the north, in northern India, Indo-Gangetic plain. Recently, about a year back, there was one initial load test was conducted on pile, and unfortunately, the pile did not perform satisfactorily. So that gave us some concern. Along my co-author, Mr. Vijay Raman, he was very much concerned. Why not to share our experiences, and that's how this paper is here. As we know that why we perform the initial pile loads, there are so many reasons. One or more of the reasons that I have already listed here. But why a pile may not perform satisfactorily during load testing? This may be because either the geotechnical investigation data may not be accurate or may be erroneous, incorrect design calculation. So the method which is adopted in calculation design capacity of pile may not be appropriate. And this is the design part. When we go to the field, then it may be poor because of poor workmanship during installation of pile, bad quality of constructions. And there is a very remotely, there is a chance that there may be a vested interest in filling the pile. Now, as we know that whenever the pile is installed, we cannot inspect it later on. It's very remote chances that we will exhume the pile and then we'll examine it what has gone wrong. So therefore, it requires a very considerable experience in design in choosing the correct soil parameters, and at site, specialized skills for piling team, and reliable workmanship in construction of pile foundations. The unsatisfactory behavior of a pile raises questions whether it was due to negligence, that is failure in selecting proper design parameters or in selecting proper pile installation technique, or was it due to ignorance, that is the lack of knowledge and information regarding soil characteristics or proper workmanship. That means the piling gang is not aware of the specification requirement. Now, our findings I will present through a case study, and based on which how we formulated do's and don'ts for piling work and shared with our experience. Now, this case study relates to a project of NTPC in Uttar Pradesh. The subsurface conditions, as can be seen, generally it's silty fine sand followed by sand and some intermediate layers of clay silt, and SPTN value is more than 30 beyond 15-meter depth. The design capacity of 760 diameter pile was 250 metric tons, 27-meter length below cutoff level, and the termination criteria was SPT should be more than 50, and there was some 4 times diameter into that strata. The sheeting was required. Now, the initial test pile was installed without waiting for the test results. The agency went ahead with the installation of working piles, and at their own risk and cost. But when the initial load test was done, the pile capacity as per the IS 291 criteria was just 140 metric tons as against the rated capacity of 250 metric tons. Accordingly, a routine load test was also conducted on 760 dia pile, and there also we could not get the desired capacity. So what might have gone wrong? We went through all the piling records, and what we found that the continuous circulation of bentonite slurry was not maintained. Further, while withdrawing the keli, the bucket, and the other cutting tool, the slurry level was getting dropped, and they were not refreshing with the fresh slurry. The density of slurry was 1.6 gram, very thick slurry at the bottom of the pile bore, and lowering and withdrawal of bucket was very rapid without rotation of tool, leading to suction effect at the bottom. Further, there was considerable time gap between end of boring and start of concreting. It was 13 hours, and that also led to 5 hours 50 minutes in completion of the concreting. Flushing by airlift technique was specified in the specification, but it was not effective, and they were doing only in single stage. That is before lowering of the reinforcement cage. And the strata was primarily silt, which was non-plastic. Now we specified whatever specification was given. We were interested to see whether they are doing this pile as per the specification.
Last 1 minute.
Yes, sir. So we witnessed this, and we both the authors were present there during the witnessing of another test pile, and then we found that the test pile which was witnessed by us, it took just 2 hours 25 minutes in the installation of the boring work. Density of bentonite was maintained as per IS code, and then this time gap between end of boring staff concrete was just 6 hours, which included even conducting SPT at the pile termination level. And within 1 hour and 10 minutes, they completed the concreting, and the SPT at pile termination was 104. So that was more than the requirement of the specification. This picture shows the SPT at the termination level. The SPT sample can be seen, silty sand. This was actually the air flushing technique was modified during that trial operation. And because they were directly putting the air flushing, that pipe directly at the bottom of the pile bore, which was agitating and was disturbing the pile bore bottom. So this was modified at the tip, J type which was introduced for flushing the air.
Mujjo sir, kindly go to the conclusion.
Yeah.
Time is already up. Kindly go to the conclusion.
So the conclusion is that a successful pile load test provides an assurance of the satisfactory behavior of untested job piles. So therefore, it is very important for us to conduct the initial load test properly. The unsatisfactory behavior of pile was primarily, in this case, due to failure of the piling team to exercise the standard practice and workmanship needed for installation of board class piles, and also the piling team ignored compliance to some of the requirements of the technical specification. Learnings and findings have been shared with site engineers, emphasizing the importance of experience and skills of persons involved to achieve good workmanship, quality checks to be carried out, and overall state compliance with the specification requirements to avoid recurrence of problem. Ignorance or negligence by the persons involved may result in various problems affecting the quality, cost, and time schedule of the project. Even with advancement in design engineering, file installation techniques, so many methods of design and software available, the skill, experience, and judgment of an individual plays an important role in successful behavior of the file under loading. Thank you very much.
Thank you, Maria. Thank you very much for the presentation. Now, is anybody present for TH0332 and TH0335?
Just to add a line, I think it was apparent bentonite was the issue. Probably 200 tons was the ultimate friction. It kept plunging. So, yeah. Okay.
Right. So, Suhail Qureshi, can you start your presentation?
Yes, sir. Am I audible?
Yeah.
Okay, sir.
So try to finish in 5 minutes time. So performance of Barrett Foundation in sandy soil subjected to vertical loading. So that is the title of his presentation.
Sir, is my screen visible?
Not it.
Okay, so now it might be.
Yeah, it's coming up.
Okay, so good afternoon to all. I'm gonna today present my presentation on the performance of Barrett Foundation in sandy soil subjected to vertical loading. The authors are Sohail Qureshi, that is me, and SW Thakur sir and Dhatak sir. So introduction, why we need this file. This file is required where the bearing capacities are high and the settlements have to be within the permissible limits. These are generally the cast in place piles. These piles are also called as wall type piles because it has a higher length and very short breadth. So it resembles a shape like a wall. The Barretts have larger bearing capacity when it is compared to conventional circular pile. I'm here comparing it to the conventional circular pile because we'll gonna compare the same concrete area and keeping it the same volume but having different shapes. Therefore, the Barrett provides resistance to horizontal stresses and bending moment very good and very better as when compared to the conventional circular pile. As rectangular Barretts are having high specific area, we are designing it for the same circular area, taking the same circular area and then reforming it the shape into a rectangular. Therefore, when it connects, it has a very high specific area. These are very compact, economical, and reliable foundation systems. The main difference between the circular pile and a Barrett pile is the shape and the equipment used for its construction. The equipment used for its construction are grab bucket and hydroparesis type of drilling tool. The the various shapes of Barrett piles are rectangular, cruciform, T-shaped, L-shaped, and H-shaped. So this is the construction procedure of a Barrett foundation. First, a drilling is to be done. While drilling, we are keeping the bentonite slurry up to the ground level, further leading to the inserting of the reinforcement cage and followed by the concreting. Here you can see the type of drilling tool which is used for the construction of the Barrett, and this is some reinforcement of a rectangular Barrett. So it advantages. So using a hydraulic grab and reverse circulation to cutter technology, we can get enough amount of desired socket length even within the bedrock or the hard strata or rocks. When compared to the same circular pile, Barrett provides 35% higher frictional surfaces. Combining if in a site there are a number of Barretts, and if we connect all through to a mat, just like a mat foundation, it would be a very high resistance structure as compared to the isolated Barrett. This process is very economical as it does not require lowering of the groundwater, and also the bentonite slurry is kept up till to the ground level. For equal depth and equal cross-sectional area, rectangular Barretts excavated under bentonite can mobilize much higher and greater lateral friction when compared to the both piles of circular cross-sectional area. A single Barrett can replace a group of conventional circular board pile as it has a higher length and very short breadth. So as when we can replace a number of circular pile and place a single rectangular barrette, it will take higher vertical load as well as give a higher frictional surface area, which will lead to higher uplift loads and also vertical loads. So literature review, I'll skip this. Okay. So the need of research for this topic was as number of numerous studies has been done only on the rectangular types of barrettes. These studies are also done on rectangular barrette, but very less on the other shapes of the barrette. And experimental studies, as I found, only one of the paper was done for the experimental purpose. So there was very much less papers and research available for the barrettes of different shapes also. And the objective of my paper is to carry out experimental investigation of the barrette foundation of various shape resting in cohesionless soil. It would be different, the parameter varying would be the different shapes of the barrette and having the same cross-sectional area that of the circular barrette, and applying the vertical loads. The test setup consisted of a loading frame, hydraulic jack, test tank, proving ring, and the dial gauges. The test tank model for this project was of 0.9 meters length, 0.5 meter width, and 0.65 meter of height. The steel tank was made of a steel frame. The bottom and the vertical edges of the steel tank was stiffened as to avoid lateral yielding during the loading phase. The hydraulic jack used for the loading gear was of 100 kilonewton capacity. The displacements were measured with the help of the dial gauges having a 25 mm travel and the least count of 0.01 mm. The dial gauges were
You
fixed.
have 1 minute. 1 minute, please.
Okay. So these are the this is the test setup, and these are the different shapes of pile, barrette pile, model barrette pile. These barrette pile was made with the help of aluminium. It was casted. So the sand properties are this. Okay. So the results and discussion. So when we found conducted vertical load test and plotted the graph for the pile, we found that the conventional circular pile took a load of 120 newtons. Okay. It was in medium dense, that is a 40% was the relative density. When it compares to the rectangular barrette having L by B ratio of 2, 3, and 4, and the area cross-sectional area was same as that was of the circular pile. So here we can see as the aspect ratio increases, the bearing capacity, vertical bearing capacity of the barrette pile increases. And when it was in different shapes like H, cruciform, and T shape, the T shape has taken the most load in the vertical loads. Okay. So these are the numerical presentations. So circular took 120 newtons. The other shape of barrette took 134 and 142, which is an increased loading. As in H shape, cruciform, and T shape took more amount of loading. So here in the graphical presentation, here we can see that the T shape has taken 83% more vertical load as compared to the conventional circular load, and then cruciform and H shape. So here we can see that 0 to 20% of increase in the vertical capacity in the rectangular barrette, as well in other shape, that is the H, cruciform, and T shape, took more capacity, very increased.
Yeah,
Yes, conclusion. With the higher surface area, barrette offers high skin friction due to which the vertical loading capacity increases. The ultimate vertical loading capacity of various shape of barrette, that is rectangular H shape, cruciform, and T shape, are higher as compared to the circular pile of same cross-sectional area. In case of rectangular barrettes, the ultimate vertical capacity increases with increase in the aspect ratio, and the highest was of T shape, that is 83% higher. These are
Thank you, Suhail. So, thank you very much for the presentation. Now, let us move on to the next presenter, Rishikesh RB. And Rishikesh, you can start screen sharing. And his topic is numerical analysis of plate anchors in clay.
Hello.
Yeah, Rishikesh, you can go ahead.
Am I audible, sir?
Yes.
Sir, is my screen visible?
Yeah, you can make it your full screen.
Yes. Good afternoon to all. My name is Rishikesh Bednake, and my topic was numerical analysis of plate anchors in clay under guidance of Professor A.I. Dathar sir and Thapre sir. These are the contents of my slides. Introduction, soil anchors. Basically, soil anchors are the deep foundation geotechnical members which are used to resist the uplift load, lateral load, and overturning movement in order to maintain the stability of the structures. Generally, it consists of the central shaft and which on which a number of plates are welded along the shaft. They are made up of various materials used for the projects of the retaining structure, deep excavations, transmission tower, pipelines, etc. So these are the basic applications of the soil anchors. In first image, we can see that the installation of the helical anchor with the hydraulic motor, and in the images we can see that they are used for the submerged pipelines as well as the underpinning of the foundation. So these are the also another application of the foundation used for the foundation underpinning. They are also used for the tieback purpose in the sea walls, submerged pipelines, and transmission tower. Literature review. Professor Ghosh in 2019 carried out the numerical analysis on the ultimate pullout capacity of the isolated helical anchor in the homogeneous soil. They found that the uplift
Yes, you
capacity of
can
the
skip
helical
the
anchor
literature review
increases
and
with
go to
increase.
your work.
Okay, so the aim of my project was to determine the ultimate uplift capacity and lateral load capacity of the plate anchors, for which I have used the FEM software. These were the four types of the anchors which I have used for my analysis. First was the circular plate anchor. Second was the square plate anchor. Third was the star plate anchor, which have a shape of the cruciform for the plate, and fourth was the helical plate anchor. These were the geometry generated in the Midas GTS NX. The second step was to automate the anchor with the soil model. Next method was assigning the material properties and to generate the meshing. These were the meshing generated for the different types of anchors. These were the parameters which I have used for the analysis. Uh, eight configuration eight type of configuration were used for the analysis in which the embedment ratio was varied for the anchors or single plate anchors. The SP by D ratio, which was the spacing by the diameter of the plate ratio, was varied for the six type of anchors in which C6, C5, C4 were the anchors of the double plate anchor and C3, C2, C1 were the triple plate anchors as shown in figure below. The performance analysis. The results were obtained from the analysis of the circular, square, helical, star-shaped anchors for the uplift loading for all type of configurations. Following are the figures for the uplift load versus displacement curve for C8 to C5 configuration of the plate anchors. Next figure denotes that the uplift load versus displacement curve for C4 to C1 type of configuration. The performance of the analysis was checked for the lateral load capacity to determine the lateral load capacity in the cohesionless soil. Similar 8 configuration were analyzed in the Midas GTS NX for finding out the lateral load capacity. This is the lateral load versus lateral displacement curve for C8 to C5 configuration of the plate anchors. These are the lateral load versus lateral displacement curve from C4 to C1 configuration of plate anchors. Following were the ultimate uplift load capacity and ultimate lateral load capacity table for after
Hrishikesh, you have
carrying out the analysis in which
1 minute,
these
please.
were from which we can see that the yes, sir. The C8 configuration was the most efficient among the all, which was having the three plates with the maximum SP by D ratio. Similarly, the ultimate lateral load capacity, it was seen that while increasing the number of plate, it does not make an much change in the load carrying capacities of the anchor, which was slightly same. For the performance of multiple plate anchors in clay, in which we can see that helical anchor was most efficient in case of double plate as well as in case of the triple plate anchors. Following were conclusions based on my analysis of plate anchors. The ultimate uplift load capacity as well as lateral load capacity of single plate anchors increases with increase in embedment depth ratio in the cohesive soil. The ultimate uplift load capacity as well as lateral load capacity of all double plate and triple plate anchors increases with increase in SP/D ratio. The ultimate uplift and lateral load capacity of a plate anchor increases with increasing number of plate. It was seen that the ultimate uplift load capacity of the double plate anchor and triple plate anchor is slightly higher as compared to the single plate anchor at H/D ratio is equal to 4. Single plate square, single plate star, and helical anchor has an higher ultimate load carrying capacity than the single plate of the circular plate anchor. Similar was for the double plate anchor. Triple plate square and triple plate star anchor and helical anchor has a higher ultimate lateral load capacity than the triple plate circular anchor in the cohesive soil at SP/D ratio is equal to 1.5. These were the references which I have used.
Thank you, Rishikesh. Thank you very much for the presentation.
Thank you.
Now let me call upon Lalit Ambedkar to start his presentation.
Yes,
and
sir.
he will be performing, his topic will be on performance of helical and square plate anchors in oceanless soil. So over to you, Lalit.
Can you see this screen, sir? Hello?
Yeah, your screen share is visible.
Okay, sir. Good afternoon, sir. My name is Lalit, and today I'm giving the presentation on performance of helical and square plate anchors in cohesionless soil. First of all, we'll see what is the anchors. Anchors are foundation systems that are designed primarily to resist uplift load, and many anchors are used to resist compressive as well as lateral loading, and this combination of the uplift as well as lateral loading. Anchors can be classified in three basic categories. One is spread anchors, second one is helical anchors, and third one is the grouted anchors. So these are the figures of spread anchors. In these, circular anchors, square anchors, strip anchors, and rectangular anchors will go on. And these are the left side shown the placing position of the spread anchor, that is vertical, incline as well as lateral. The next one is the helical anchors. Helical anchors consist of shaft and the helix, that is single helix, double helix, triple helix, and quadruple helix. And helix, number of helix are dependent on the length of the shaft. If in case of deep foundation, length of shaft is more, then we can increase the helix accordingly. Third one is the grouted anchors. In case of grouted anchors, we drill the tendons and then grout can be inserted for giving the fixed beam. Area of application. During the excavation, we can use the anchors for slope stabilization and for transmission towers to reach whenever it will be subject to uplift forces to reduce the water movement. In pipelines, we can use the anchors to prevent the water. And for heavy pipeline compressive load also we can reduce by providing the anchors instead of the any deep foundation. Below the building, we can use the as a foundation support anchors. Advantages of helical anchors: they are quick to install and there is no need of equipment in comparison with other type of this foundation construction. Installation of helical anchors are up to 20 times faster than the driven piles. No spoil produced during the process of installation. They produce small or no vibrations during the installation, decreasing possible damage to the structure from soil movement. Easy installation and there is no need for extension, and they can be installed in different area also. These are the model anchors prepared for square anchors and helical anchors. These are the specification of anchors. Cohesionless soil is used. Type of anchors is helical as well as square. Diameter of shaft is 10 mm. H/D ratio considered 3.5, 4 and 4.5, and SP/D ratio is 1:1. Here, experimental investigation I have done for anchors. So this is the process for sending that using rainfall techniques. Sand is poured into the tank. This is the vertical loading applied on anchor. Performance of single plate anchors. These are the results. In case of single plate anchors, we can see the ultimate uplift load capacity as well lateral capacity is more than the anchor. This one is by using double square and double helical plates. Here also we can see the here I change SP/D ratio, that means spacing between the helical and square anchor. So here we can see that the helical anchor capacity is more than that of square anchors. As they are providing more uplift and lateral load carrying capacity. The ultimate capacity single plate helical anchor is up to 20% greater than that of single square plate anchor. The ultimate lateral capacity of single plate helical anchors is up to 4% greater than that of single square plate anchors. The ultimate uplift capacity of double and triple plate helical anchors is further that is 15% greater than that of double and triple square plate anchors. The ultimate lateral capacity of double and triple plate helical anchors is up to 30% greater than that of double and triple square plate anchors. Thank you.
Thank you, Lalit, for the presentation. And if time permits, we will come forward with the questions later on. Now, let me call upon Sunil Digge for his paper presentation. And start uploading. You can start uploading. And the title for his talk is Performance of Barrett Foundation in Sandy Soil, Subjected to Lateral Loading. Over to you.
Is my screen visible, sir?
Not yet. Okay. You can present now.
Good afternoon, everyone. My name is Sunil Digge. Today I present a presentation on my paper presentation topic Performance of Barrett Foundation subjected to lateral load in the sandy soil under the supervision of Dr. A. Datrak sir and Professor S.W. Thakre sir. These are the contents of my presentation. Let's begin with the introduction.
Your screen is not visible. Can you once again do that presentation? Can you again restart? It's not visible for us.
Now visible, sir?
Yeah, now visible. Yeah, go ahead.
Good afternoon, everyone. My name is Sunil Digge. Today I present a presentation on my paper presentation topic Performance of Barrett pile subjected to lateral load in the sandy soil under the guidance of Dr. A. Datrak sir and Professor S.W. Thakre sir. These are the contents of my presentation. Let's begin with the introduction of the Barrett Foundation. Barrett Foundation is an cast-in-place reinforced concrete pile which would able to take high axial loads and high moment in a comparison to the circular pile of the same cross-sectional area. The ideal site for its implementation is the boulder ground and alluvial soil, but we can adopt it to the various types of the soil. Figure shows the various shape of the Barrett Foundation. The purpose and design of the Barrett Foundation is very much similar to the piles, and the Barrett pile is generally rectangular pile. The use of the Barrett pile as the foundation of a high-rise building becomes very popular in a recent year because of its sufficiently larger bearing capacity compared to the circular pile. The application of the Barrett pile generally done to a structure where bearing capacity requirement is high, such as elevated expressways, overpass bridges, subway station, and etc. The main difference between the Barrett pile and circular pile is in the shape and equipment used for its construction. The equipment used for the construction of the Barrett pile is the grab bucket or hydropressure type drilling tool, which is shown in the figure. Literature review. In 2013, Wakil had presented a paper on the small scale rectangular Barrett which is rested in the sand to study the effect of sand relative density, aspect ratio, and etc. And from this, they have concluded that with increasing aspect ratio, performance of the Barrett pile increases. Sand relative density has a significant effect on the lateral performance of the Barrett pile. Performance along the major axis is better than along the minor axis. Experimental investigation. The experimental investigation consists of a test tank which was fabricated from the mild steel having a thickness of 3 mm. In figure second shows the loading frame which was used to apply the static lateral load by using the frictionless pulley and non-extensible rope of one end is connected to the pile cap and another one end is connected to the loading hanger to apply the standard weights. This is the photographic view of the model pile Barretts and over which a sand material is placed to give resistance while applying the load. This is the test material I have used which was found in Nagpur region of Maharashtra, and this is the properties of the sand. calculated. Experimental test procedure. The experimental test procedure, for preparation of the sand bed to achieve the desired sand relative density rainfall technique was used. And after the filling the bed was level and it is checked by the spirit level. And while placing the pile in the sand bed, undisturbed pile installation method is used, and which carried out by using a special steel rod, which is shown in the figure. This is the schematic representation of the lateral or applying the lateral load. This is the parameter I have selected for the present investigation. Test results. Performance of the circular pile. The ultimate lateral load was taken when the lateral displacement equal to 5 mm and which was calculated equal to 28 mm. This is the performance of the rectangular barrette with three different aspect ratio 2, 3 and 4 which was loaded along the major axis. And this is the similar case, but load was applied along the minor axis. And from this performance, ultimate lateral load for three different aspect ratio shown in this table, along the minor axis, along the major axis. This is the performance of other shape barrette, H cruciform T-shape barrette, but load was applied along the web. And this is the similar case, but load was applied across the web. And from this performance, ultimate lateral load calculated shown in this table. Discussion. This is the graph of the percentage increase in capacity with respect to circular pile.
Last 1 minute.
Yes, sir. This is the performance of rectangular barrette for minor loading along the minor axis and loading along the major axis. For major axis, with increasing aspect ratio, performance increases. This is the performance of the other shape barrette with respect to circular pile. Conclusions. Barrette pile has a higher performance in a comparison to other pile. Performance along the major axis is greater than minor axis. With increase in aspect ratio, performance increases. Fourth conclusion, for aspect ratio 4, performance among the all barrette pile is higher. And last conclusion, cruciform shape barrette performance is better than other shape barrette.
Thank you, Sunil. Very interesting presentation. And if time permits, we'll have the question and answer session towards the last. Now, may I call upon Himanshu Verma to share his presentation. And the topic of his talk will be on performance of the helical pile foundation in oceanless soil by Anand ID, Himanshu R. Verma, Minal MD, and Sanjay W. Hello.
Sir, am I audible?
Yeah, Himanshu, you are audible.
Okay, my screen is. Good evening. Now, I am Himanshu Rajesh Verma, presenting a seminar on performance of the foundation in soil.
Himanshu, your screen is not clear. I think Himanshu, your screen is not fully come at. Yeah.
Just a second, sir.
Yeah, continue. Okay. Now it is visible. Go ahead.
Okay. Introduction. Helical piles were invented by Alexander Mitchell in 19th century. A typical helical pile consists of one or more pitch helical bearing plates affixed to either a central square or circular pipe, as shown in figure. The helical piles are installed into the mechanical torque at its driving head. A helical pile can be installed with low noise and low vibration. Their current application includes residential and commercial buildings, bridges, solar farms, light poles, wind turbines, machine foundation, and many other structures. These piles comes with many advantages and disadvantages. The advantages are easy in installation with relatively small equipments, rapid speed of installation. Installation can be installed in case of high groundwater table. Therefore, no need of dewatering the groundwater level. Helical pile provides high compressive capacity as well as high uplift capacity. Immediate loading can be applied after the installation. Disadvantages: slender shaft do not resist large lateral loads. Buckling can occur. More difficult in penetration. In dense and rocky soils, corrosion may occur after a certain period of time, but it can be taken care of by applying a certain non-corrosive coats. Literature review. Many studies have been conducted by Zaid et al. And M. Stark, where they have conducted a field testing and numerical analysis. Also, the B. George et al. In 2019 also conducted the helical pile installed in cohesionless soil by displacement and non-displacement method. They have conducted a laboratory experiment as well as the numerical analysis, and then they have compared both the laboratory and numerical model. The pile installed by displacement method exhibit higher ultimate capacity and distinct failure pattern as compared to the pile installed by non-displacement methods. This is my system development which I have used in the project. Here you can see a helical pile with 3 helix which we have varied. Then we have developed a finite element model. This is the finite element model. As you can see, the size of the finite element model was kept 15 times the size of the maximum helix blade used. The pile shaft and the helix were modeled as linear isotropic material. Soil was modeled using 10-node tetrahedral element. An interface element was introduced between the helical plate and shaft and the soil to account the interaction between the soil and the helical pile. These are the properties assigned to the helical piles and the soil layer. These are the parameters which we have varied during the numerical analysis, such as type of loading, axial, uplift and lateral, helix diameter. We have varied the different helix diameter and number of helix in a single pile. Then interhelix spacing, which is the spacing between the 2 helix. Interhelical pile spacing for group analysis, and number of piles in groups. Results and discussion. The nonlinear analysis was carried out after the mesh generation, considering the different pile geometry. For helical pile, a failure settlement criteria of 5% was adopted, whereas 12 mm displacement at pile head was considered for lateral loading conditions. For conventional pile, a settlement criteria of 10% of the shaft diameter was considered. Then we have performed the different nonlinear analysis and load settlement curve was plotted. And then we came up with the ultimate capacities, and these were plotted with different helix diameter ratio. As you can see, as the helix diameter ratio increases, the ultimate vertical and uplift capacity also increases. But in the case of lateral capacity, the ultimate capacity increases up to the helix diameter ratio 2 and further decreases. So we can say that the optimum helix diameter we can use as 2. Then we have conducted the interhelical spacing ratio analysis on interhelical spacing ratio. Here also you can see that as the interhelix spacing ratio increases up to 3, the ultimate load capacity also increases and further remains same.
Mangsu, you have 1 minute, please.
Yes, sir. Yes, sir. Then we have conducted then we have determined the effect of number of helix. As you can see, as the number of helix increases, the vertical and uplift capacity also increases. But in the case of lateral capacity, the helix with 3 helix gives greater results. Then effect of interhelical pile spacing. As the interhelical pile spacing ratio increases, the ultimate load capacity also increases up to 3 and further remains same. Then performance of group of helical piles. As you can see, the helical piles are compared with the conventional pile in group. As you can see, they have a helical pile perform very much better as compared to the conventional pile. Then conclusions: the ultimate vertical and uplift capacity of the helical pile increases as the number of helices and diameter of the helix increases. The optimum ultimate lateral capacity of the helical pile is achieved at helix diameter ratio equals to 2. The optimum interhelix spacing ratio of the helical pile is equals to 3. The ultimate vertical and uplift capacity of single helical pile is higher up to 160% to 600% relatively as compared to the conventional circular pile. The percentage increase in lateral capacity is significant only in the case of pile with 3 helices. with increase in number of helix, about 100% increment in uplift capacity, ultimate vertical capacity, and 350% increment in uplift capacity, and about 35% increment in lateral capacity is observed. The ultimate vertical capacity, uplift capacity, and lateral capacity of the group of helical piles is higher up to 200, 500%, and 50% respectively as compared to the group of conventional circular piles.
Thank you, Himanshu.
These are the references which I... Thank you, sir.
Thank you very much, Himanshu, for the presentation. Now may I call upon Shayesh Kolcha for his presentation, and
Hello.
you can start sharing right now.
Hello, am I audible, sir?
Yeah, you are audible. You are audible. You can share your screen, Shayesh.
Yes, sir. Yes.
The topic of his presentation is analysis of pile group and pile draft as a foundation system by Sreyash Kumar G, Jay Kumar Shukla, and Nitin H. Joshi.
Sir, is my screen visible?
Not at Sreyash.
Not. 1 minute. Now, sir?
Yeah.
Okay, sir. Good afternoon, all of you. My topic name is Analysis of Pile Group and Pile Draft as a Foundation System. My scope of the my model and the topic is the investigation is in the software Flag 3D, which is based on finite difference method, and the analysis is done in both pile group and pile draft. And I had taken the two soil layer, which is approximately sandy soil, which has different Young's modulus, and the pile group does not touches the underlying soil, and it is 500 mm above the ground surface. And the pile raft top level is similar, is in level with the ground surface level. And in this, I had applied the load in two ways, which is concentric load at the center of the pile cap and the pile raft. Sorry, a pile cap and the raft. Here I am denoting the pile cap with the pile group, and I am denoting the raft with the pile raft. And I had applied UDL over the whole pile cap and pile raft. I have taken the variation in the pile cap and raft thickness, that is 800 mm, 1000 mm, 1200 mm, and 1500 mm. And I had also varied the number of piles, that is which are 4, 6, 10, and 20. And my objective is to analyze what is the effect of the pile group and the pile draft, and also what is, or if we will change the different load pattern, that is point load and UDL, what is the effect, and also to find the differential settlement, maximum bending moment, and maximum shear force in pile under different conditions. Also, I want to examine the amount of load shared by the different piles and the raft under different conditions. Now, I'd also done the model validation in Flag 3D, which is based on the paper Van Impe. Here, there are 9 piles, and raft thickness is 0.5 meter, and the length of pile is 10 meter. And here the pile material property is the linear elastic, and the raft is also linear elastic. Now, while analyzing this model paper of Van Impe in the Flag 3D, I had come under the following results. This blue line is of Van Impe, and this orange line is of my present study. I analysis his 3 graphs, the total load, maximum settlement, and the difference settlement with respect to raft thickness, and the total load is from is versus center settlement. And I had found that approximately valid result by comparing it. So I had worked on my present model by after validating this Van Impe. And this is my present geometry which I had worked upon. This is a pile drop model in the left side, and the right side is a pile group model which is 500 mm above the soil. Now the material property I have taken I have taken almost a sandy soil which is from 50 about, which is about 50 meter, and I have changed mostly Young's modulus. The pile material property is a 0.8 meter diameter, and the length is 35 meter. And mostly I've taken the concrete pile, which is cast institute pile. And the pile cap or the raft material property is also similar to the pile property. And the visual analysis, as I've done in the Flat 3D software, which is based on finite difference method. So in this, I have taken that that brick zone of brick type, as it consists of many different types of zones. But I have taken brick type, and the soil I have taken the more column. Here in the graph, there is a abbreviation and the notation. These are my abbreviation notation, which is PG for pile group and PR for pile graph. And it is and rest is shown on the screen. And first of all, I have applied a load for 4 pile configuration, and the load applied, point load, is 8,000 kilonewton, and UDL applied is 500 kPa. And it is based on these loads are based on the safe load capacity of the pile group. Now this is my on the left side, this is my model, and the right side.
Jans, you have 1 minute.
Yeah, sir.
Please.
Yeah. And the differential settlement and the pile cap raft thickness, as it shows that as the raft thickness varies, the differential settlement decreases. Now and in this slide, the leftmost left graph shows the pile cap and raft thickness variation. It shows that the maximum bending moment of the maximum bending moment of pile on the raft. Here, as the pile cap and raft thickness increases, the maximum bending moment increases, but it does not vary much. And also it is case in the maximum shear force. Now I have also analyzed about six pile configurations, and and for 10 pile configurations, the pattern is almost the same. And as the differential as the pile cap and raft thickness increases very much up to 1500 mm, and differential settlement is almost constant about 8. And this is for my 20 pile configuration. This is my 20 pile configuration, which is 4x5. Now I am coming to the conclusion. Here I have seen that as pile cap or raft thickness increases, the differential settlement has a good effect. Differential settlement increases in a good amount, but does not affect much to the maximum bending moment, maximum shear force. Also, that and in pile group and pile draft, compared to pile draft, the pile group as a high differential settlement and maximum bending moment, maximum shift is also high. And and comparing to that point load and concentrated load and the center and the UDL over the pile cap and draft, that if the loading is uniform, then the differential settlement is very negligible. These are my references.
Yeah.
Thank you, sir.
Thank you, Fresh. That was a good presentation. Now, may I call upon Minal Dage for the presentation, and the topic will be experimental investigation on performance of helical pile in cushion-less soil by Tatrak AI, Pinalam Dage, Himanshu R. Verma, and Thakre SW.
Good afternoon, everyone. I am Minal Dage, and topic of my presentation is experimental investigations on performance of helical pile, guided by Dr. A.I. Thatrak and Professor S.W. Thakre. These are the content of my presentation. Let's start with introduction. Helical piles were invented by Alexander Michel in 19th century and were patented in London. Helical piles are made up of a steel shaft, either a solid square shaft or a circular pipe. Helical piles are installed by applying a torque to the top of the pile by using torque motor. These piles were first used as a foundation for Maplins and Lighthouse in England. Applications of helical pile. Helical pile is used as a foundation for solar farms, residential and commercial buildings, wind turbines, offshore structure, bridges, and also for foundation repair work. Objective of my research are to study the behavior of single helical pile under different loading conditions, that is vertical, uplift, and lateral loading. To study the behavior of helical pile with varying helix diameter and number of helixes. Experimental work, cohesionless dry clean Kanhan sand of Nagpur region passing through 2 mm ISP was used. These are the different properties of sand. These are the model helical pile with a different helix diameter and number of helixes. Figure 3 shows the dimensions of model helical pile. 21 tests were done on this pile, and the results and their results compare with conventional circular pile. Experimental test procedure. Relative density of sand bed was maintained by using sand draining technique, and non-displacement method of pile installation was used. Initially, the required height of a sand bed was prepared by using sand draining technique. After that, the pile is placed at the center of the tank, and remaining tank was filled by using the same technique. Pile was positioned vertically by using a special guide. These are the test setup for vertical, lateral, and uplift loading. Hydraulic jack is used for the application of vertical load. Uplift and lateral load are applied with the help of wire and pulley arrangement. These are the failure criteria used for the helical pile. Ultimate vertical load was considered as the load at which displacement equals to 5% of the helix diameter, and for the lateral load, 5 mm criteria was used. The ultimate pull-out load was considered as the load at which sudden pull-out of the pile occurred. These table shows the details of constant and varying parameters. Length of the pile, shaft diameter, relative density were kept constant. Type of loading are axial loading, lateral loading, and uplift loading. Helix diameter ratio were varied as 2, 2.5, and 3, and number of helixes as 1, 2, and 3. Result and discussion. These are the load settlement curve for conventional circular pile, and table shows the value of ultimate load capacity. To study the effect of helix diameter ratio on the capacity of helical pile, helix diameter ratio were varied as 2, 2.5, and 3. These are the load settlement or displacement curve for the helical pile with different helix diameter ratio, and the values of ultimate load capacity are given in the table. This graph shows that the ultimate vertical and uplift load capacity increases with increase in helix diameter ratio. In case of lateral loading, as the helix diameter ratio increases, lateral load capacity decreases, and lateral load capacity is maximum for helix diameter ratio equals to 2. To study the effect of number of helixes on the capacities of the helical pile, helix diameter ratio is kept constant, which is equals to 2, and the number of helixes were varied as 1, 2, and 3. These are the load settlement. Yes, sir.
Yeah, Vinay, you have 1 minute, please.
Okay, sir. Table shows the value of ultimate load capacity. This graph shows that as the number of helixes, ultimate vertical, uplift, and lateral capacity also increases. Conclusions: the ultimate vertical uplift capacity of the helical pile increases with increase in helix diameter ratio. The maximum ultimate lateral load capacity of the helical pile is observed at helix diameter ratio equals to 2 and further decreases. Up to 99% increment in vertical capacity is observed with varying helix diameter ratio as compared to the conventional circular pile, and up to 45% increment in uplift capacity is observed with varying helix diameter ratio. The ultimate vertical, lateral, and uplift capacity increases with increase in number of helices. These are the references. Thank you.
Thank you, Minal, for the good presentation. Now, may I call upon Sujan Kulkarni for his presentation. You can upload your presentation. And the topic of the presentation is Instrumented Pilot Test in Southern India by Sujan Kulkarni, Ravi Kiran Vaidya, and Sriram P. Over to you, Sujan Kulkarni.
Good afternoon, everyone. Hopefully my screen is visible to you now.
Yeah, visible. Go ahead.
Hello. Hello.
Yeah, you are visible. Please go ahead. You can make it into full screen, presentation mode.
Yeah, can you hear me now?
Yeah, we can hear you.
Okay, great. Okay, I thought my voice is not.
Make it into full screen.
So, today I'll be presenting this interesting case study where we instrumented. It is in full screen.
It's still in.
Today I'll be presenting this
full screen, slideshow full screen. So it will be more clearly visible for my person.
Hello.
Yeah, if we can make it into full screen for a slideshow, then it will be more clear for all of us.
Sorry, say that. Hello.
Yeah, fine. Go ahead, Sujan Kulkarni.
Okay, so I'll start with this interesting case study for the instrumentation that we performed back in 2012 for Kochi Metro project. Specific outline will be introduction, subsurface conditions, and then I'll go over these load tests that we performed, and finally I'll conclude my presentation. So basically, conventional vertical load tests only provide us the information about applied load and pile height displacement at the top, and there is no quantitative information such as load transfer behavior or what is the mobilized skin friction, what is the end bearing. All those details are we cannot get it when we perform conventional load tests. Similarly, when we perform lateral load tests, we only get the load deflection curve at the top of the pile. However, what actually the designer requires is the point of fixity and the load deformation curve along the depth of the pile. So to fulfill this objective, we can instrument the pile and we can get all this information which is critical for pile design. Now, back in 2012, a monopile with a diameter of 2 meters and length of 50 meters was planned for Kochi Metro project. And note that this was one of the first attempts to adopt monopile system for metro projects in country. So what we come up with the idea of instrumenting the vertical and lateral load test so that we get additional information while we perform the conventional load test. So we installed embedment type strain gauges along the depth of the pile, and so as to get the skin friction and end bearing distribution in the pile. And also we install inclinometer casing, so we get the point of fixity along the load deflection curve at different depths of the pile. Note that we also performed cross-hole sonic logging test, and which concluded that the pile had major defects from 44 meter to pile toe. So that information was quite useful at later stage. But to summarize the subsurface conditions, mostly as you must be aware, this Kochi has lot of these marine clays. So most of the soil profile consisted of this fine-grained soil with silts and clays, and it was highly stratified soil stratigraphy with intermediate with some clay sands and sand. Then the design load for this pile was 850 tons. Let's discuss a few interesting facts about this vertical load test that we performed. And the design load was 850 tons, while the test load was 1275 tons. Note that all these specifications were determined by Kochi Metro. So although this was test pile, the test load was only 1.5 times load. Then for the reaction system was consisted of unique combination of anchor piles and tentlage. The instrumentation was performed by 56 embedment type strain gauges, and we attached strain gauges at various levels, not more than 3 meter, and at alternate layers of 4 numbers and 2 numbers, so as to optimize the cost as well. This is a typical picture where a vertical load test is in progress, and you can see tentlage, and there were also 4 reaction piles. This particular picture shows the strain gauge installation in progress. Now, again, the loading pattern and all was finalized by the client, and it was not as per IS, but they had the cyclic load test. They performed the cyclic load test with 5 to 6 different cycles, and the full load was maintained for 24 hours. The final load was 1277 tons, which was maintained for 24 hours, and the failure criterion was 12 mm. Then, since pile had this major defect from 44 meter to pile toe, the load carried by the pile was due to frictional resistance only. And this is the typical load settlement curve. As this was a cyclic load test, you can see multiple cycles. And at the time of testing, 9 gauges out of 56 were not functional due to Primi hitting one of the cages, and the cable may have damaged. But still, I think this was we got pretty good data with remaining strain gauges. Then the strain gauges located below 44 meter indicated unusual readings. But because we had these cross-hole sonic results, we could correlate these the unusual reading with the presence of defect. And that way we used only data above 44 meter to estimate the skin friction distribution. This is the data collection in progress. You can see so many wires and a lot of junction boxes. The findings for vertical load test, the strain gauge readings were used for calculating the load transfer at each level. Then you can see from this plot, the pretty much the upper 6 meter had no friction, indicating the fill is not contributing anything for skin friction, and there is then sudden dip, indicating lot of skin friction beyond 6 meter. Then strain gauge data obtained from gauges located beyond 44 meter, it was ignored because it was basically meaningless. And based on the available data, 89% of the capacity was derived by skin friction, while the balance 11% was from skin friction and aid bearing. Of course, it is hardly anything because of the defect. These are the load transfer curves and skin friction distribution data. Then upon completion of the vertical load test, we also perform cyclic load test.
Please try to complete it in 1 minute.
Yeah, okay. So based on the similar approach was also performed for cyclic lateral load test, and this is the cyclic load test curves. We also performed this inclinometer study along with cyclic load test curve. This is a cyclic load test inclinometer data for each loading cycle, and based on this data, we conclude that at meter there was still some deflection, indicating point of fixity is much deeper than was theoretically designed. Concluding remarks, based on CSL, the pile has major defects, and this was verified by strain gauge readings. Strain gauge readings were used to compute skin friction and end bearing. 89%, 11% that I already explained, and the skin friction estimate matched fairly well with the theoretical computations, while end bearing was much lower as pile had defect at bottom. Similarly, for inclinometer readings, they to verify a theoretical point of fixity, and which found to be deeper than the theoretical value. And lastly, due to instrumentation study provided additional data for further design. However, the idea of installation of monopile was eventually terminated due to unavailability of contractors to execute such huge piles at that time. Now it is pretty much common. And also due to the fact that the test pile had major defect at the bottom, which raised concern over practices as there was no redundancy because it was only single pile for that particular period. So thank you.
Thank you, Sujan Kulkarni. Very interesting presentation. Now, may I call upon Uday Pratap for his presentation. Uday Pratap, we can start screen sharing now.
Yes, sir.
Yeah.
Yes, sir.
And the topic of the presentation is lateral load carrying capacity of vertical monopiles by Uday Pratap, Avdesh Kumar Chaudhary, and Abdesh Kumar Singha. Now, over to you, Uday Pratap.
Sir, presentation PPT is visible?
Yeah, visible. You can make it into full screen and go ahead.
Yes. Good afternoon, everyone. I am Uday Pratap. Today, my seminar topic is lateral load carrying capacity of vertical micropile. I am a research scholar in NIT Jamshedpur. So first, we introduce content, introduction, literature review, material, methodology of the study, result and discussion, conclusion, and reference. First, introduction. In introduction, micropile are also called as mini piles and often used to underpinning. They are also used to create foundation for a variety of project type, including highway, bridge, and transmission towers. They are especially useful at a site with difficult or restricted access and with environmental sensitivity. A micropile has a small diameter, typically less than 300 diameter, and installed as a drilled and grouted pile that is typically reinforced by a solid reinforced central bars. Micropile can withstand vertical, lateral, and oblique loads. And the use of micropile has grown significantly since their concept in 1950. And the various application of the micropiles here, this is the foundation supports, soil stabilization, earth retention, reticulation of wall, and arresting structure settlement, seismic retrofitting, and etc. This is the literature review. Various researchers have been investigated the behavior of the single micropile and group of vertical micropile, which is subjected to lateral loads. And they found that the lateral load carrying capacity of the vertical micropiles increases with increase in L by D ratio, increase in spacing between the group of micropile, and group efficiency, etc. So some literature review. And the material to be adopted in this study, first we adopt bottom ash and sand. Bottom ash is the byproduct of the coal combustion, which is available in Usa Martin, Jamshedpur. And second material is sand. Sand is collected from Kharkai river bed in Jamshedpur. This is the property of the materials, which is specific gravity, classification of the soil, SP, and this is the property of the material. And the methodology we adopt the experimental analysis in this study. This is the typical model test here. This is the pile cap, and this is the micropile. The micropile is the steel micropile with a small 25 mm diameter and thickness is 1.4. The typical model test inside diameter is 75 centimeter into 75 centimeter into 75 centimeter. The micropile was installed as a square group of micropile with different L by D ratio 5, 8, 11, 13, 15 and 18 with constant spacing 3.5D and at a constant relative density at 50%, where D is the diameter of the micropile, A is the length of the micropile. And the dial gauge was attached to the pile cap to note down the horizontal deflection of the micropiles. Result, in this graph, it is clear observed L by D ratio significantly affect the lateral load carrying capacity behavior. In graph A, represent the bottom mass and graph B represent the sand. In both cases, lateral load carrying capacity increase with increase in L by D ratio at a constant spacing 3.5D because of skin friction resistance also increase. In here, the micropile failure occurs due to soil failure without showing peak point in both backfill material, bottom mass and sand. And the maximum displacement of the micropile occurs at the pile head and decrease with increase in the depth. And this is the lateral load carrying capacity value at L by D ratio 5, 8, 11, 13. And numerical analysis, we adopt that numerical analysis has been carried out through finite element software like Plaxis 3D, and the model was created by Mohr Coulomb model, and the micropile was installed as a beam element, and pile cap was created by a plate element. The dimension of the model is equal to the inside dimension of the tank. And the comparison of the experimental result and numerical, this is the experimental result at for bottom mass at L by D ratio 15, and this is the sand, this is the Plaxis, and this is the experimental result of the sand at L by D ratio 15. And finally, we conclude that in the group of vertical micropile, lateral load carrying capacity was found to be increased with increase in L by D ratio. It has also been observed that the settlement before achieving the ultimate bearing capacity decrease with increase in L by D ratio. The experiment model has also been validated with numerical modeling with Plaxis 3D. Hence, it can be opinion that the present numerical model provide the similar trend with the experimental lateral behavior of the group of vertical micropiles. So, the lateral load carrying capacity of the vertical group of micropiles show that the similar behavior on the bottom mass and sand both. Hence, we conclude that the bottom mass can also be used instead of the sand as a backfill material because of bottom mass is a effluent every day in the huge amount as industry waste, and utilization of the bottom mass is an eco-friendly. This is the references.
Yeah, thank you, Pratap. Yeah, very interesting session. Unfortunately, our time was only up to 3:30, and already we are overshooted by a few minutes. So anyway, thank Chairman for that wonderfully managing the time. We were able to complete, and the next sessions are starting from 3:45. So we won't have much time for question and answer session. Udaya Pratap, can you stop sharing the screen?
Yes, sir. Yes, sir.
So I would like to point out that out of 12 papers were presented during this session out of the 15, and very interesting session papers were there. Unfortunately, due to the lack of the time, we don't have much time for discussion. Now I thank the organizers and leave to the chairman for his concluding remark and to the session chair to find the way forward.
Thank you, Dr. Joseph. We have heard very good presentations by 12 presentators. All the papers are very good. Now, what I find that Professor Datrak AI, his papers are almost 5 papers. So a lot of contributions from Professor Datrak. And so nicely that O'Neill you have managed, and we are in time. So if they have some questions about the paper presentators, so the questions I think they can directly share with the presentators. The email addresses are there. and we don't have time now to discuss what you feel. So in that way, I think, shall we conclude, or we have one or two questions? Coordinator said, Dr. Robi, shall we have one or two questions?
I think if there are no major questions, we can conclude, because yes, each paper merits some discussion, but maybe due to lack of time, it may be difficult to go ahead with the entire question answer session. So let the participants email the questions to the respective author, which can be replied. I would also like to thank the organizers and the chairman and co-chairman for the wonderful conduct of this session, which was very much in a timely manner. And I hope everybody could present it in spite of the limited time. I think there are two things as chairman and co-chairman that you both need to do, is to select two papers for the journal, and also at least recommend, in the sense recommend two papers for journal, or whatever papers you feel for the journal, and select two best papers out of the presented papers. So that's something either we could do a con call or something to maintain the confidentiality and close the issue.
Yeah, we will go accordingly, Ravi. Yeah.
So we will discuss then, and then fine. So
yeah,
we can leave, and then
I think yeah, make a con call and put it to the organizers, and then close the sessions.
Oh,
right, sir. So we close it and we
please.
Thank you.
Thank
you. Bye.
Bye. Bye.
Amit Prashant ji, good afternoon.
Namaskar, good afternoon.
You were in this session. I didn't notice in the first.
No, I just joined.
Oh, okay. And the session is over. So sorry for that.
No problem. So I'm supposed to be coming for next session.
Oh, okay. So that's the same link. Okay.
Yeah.
Oh, okay, sir.
Hi, Amit. Rajesh here.
Namaskar, Rajesh. How are you?
Yeah, fine. Long time no say.
Yeah, that's true.
Came to know you are so busy.
Sorry?
Came to know that you are so busy in Gandhinagar. All responsibility lies on your shoulder.
I think everybody has a challenge nowadays. Last 8-9 months have been crazy.
So any plans to visit hometown?
Not until May. I think hopefully by May things should be better.
Namaskar, sir.
Namaskar, sir.
How about you, sir?
Doing well, doing well. Our theme speaker, Professor Chandan Ghosh, sent a message that he is in some other session. He is in session 6, same slot.
Oh,
And,
the theme speaker is Amit. Amit is the theme speaker.
Amit Prashant is the theme
chairman.
speaker?
Yeah,
Okay.
yes, chairman.
Okay, okay. So what we will do is that, just, see this one. So we have Amit Prashant is there in this particular session, okay, as the theme speaker, yeah, and as Professor Chandan Ghosh takes some time, maybe what I will do is that I will start the session, and Dr. Rajesh, we will conclude when Professor Chandan Ghosh joins actually. So should we start the session? Just give me. So first I will start introducing co-chair and then the theme speaker and of course chairman also Chandan Ghosh. So welcome to the the numerical and physical modeling session. When I agreed for this, I was not knowing that it runs for 2 days. Okay, so where he asked for who should be the chairman and co-chairman. Then I have actually told the names which have come to my mind. So one name which came to my mind is my former student, Dr. S. Rajesh. I'm very proud of Dr. S. Rajesh because who was here in IIT Bombay and we had sailed through all the difficult times and all. And so I'm very happy that now he is doing well at IIT Kanpur. If I'm correct, actually, I think Dr. Rajesh did his BTech from Vellore College of Engineering, Vellore, yeah, and also ME from Anna University, okay, Anna University, and then he worked for some time before joining IIT Bombay, in Vellore Institute of Technology. Then he did the PhD here, and then in 2010 or so he went for postdoc in France, particularly in Grenoble, and he worked on a very important aspect of landfill barriers, with continuation of his PhD work. And then since then he's working in IIT Kanpur. I think now he has completed about 8 to 9 years, Rajesh.
Yes, 8 years.
8 years. And so welcome, please, on behalf of the organizers of the IGC 2020, please join in welcoming Dr. Rajesh to co-chair this session. And then, I have my friend, our Chandan Ghosh. He has sent a message saying that he will join. But, he did his PhD, I know, from 94 or so from IIT Kanpur. Then he did again, one more PhD in Japan. I think during 1999-2001, because I met him in 2001 in Japan. He was still doing PhD or completed PhD. So and then he returned to India and did his long stint at NDMA, I think National Disaster Mitigation Agency, as a professor there. Then afterwards he joined IIT Jammu as professor. So I understand that he is now at IIT Jammu. And so please join me in welcoming Professor Chandan Ghosh to chair the session. He will join, he is in another session. Then my friend Amit Prashant, Professor Amit Prashant, actually, I have not directly interacted with him, but I know he was at IIT Kanpur. Rajesh, your erstwhile colleague from IIT Kanpur. And I know that he is specialized in digital image analysis of partial test and all. When I visited IIT Kanpur, they have shown, when I went to the lab, Professor Amit, they have shown the setups which you have developed and which are being used and all. So, and now I think over the past, what I can say about when you moved, Professor Amit Prashant?
2010.
So almost time runs very fast. For the past 10 years, Professor Amit Prashant is at IIT Gandhinagar, and for some time he was acting director IIT Gandhinagar and holding the responsibility and holding the mantle for some time till the same Professor Surinder Jain is reinstated. And currently, I think Professor Amit Prashant is the Dean Research and Development of IIT Gandhinagar. So Professor Amit Prashant is going to deliver the lecture on the investigation of instabilities in granular media and the numerical simulation. I think this is, one of the topics. Still, I think Arghya Das is also investigating in IIT Kanpur. So with this, now I hand over the session to Dr. Rajesh for conducting the session. And in the meanwhile, we will see when Professor Chandan Ghosh can join. Then we can see. So Rajesh, I think you must be knowing how many papers are going to be presented and all.
Yeah, I know it.
Okay. So the floor is yours, Dr. Rajesh.
Thank Professor Vishwanathan, my dear guide. It's very happy to get introduced from guide. So it's very and whatever I am today, it's all because of whatever I learned from IIT Bombay and your. And then I know personally Amit also, Amit Chan. We had some good time together for some time.
Okay.
And then may I request Professor Amit to share your screen and then can start the session.
The time, what is the time which you are giving, Amit?
So it's 20 minutes as per the guidelines.
Okay,
I'll try to finish before 20 minutes.
I think I'm seeing some 30 delegates are there. I think we welcome the delegates also.
Yes.
So, hello friends, I'm going to talk about this granular mechanics a little bit, mainly the focus on instabilities. The work is mainly coming from Dr. Debayan Bhattacharya's work at IIT Gandhinagar. He finished his PhD about 1 year back, 1.5 years back. And right now he's in with Professor Wu in Boku, which is another very prominent group in this area. And also some work has come from earlier, one of my earlier student and now faculty in IIT Mandi, Professor Maushmi Mukherjee. So what is this all about is you will see some glimpse of that in this video. I hope you are able to see that video. The message from this is it triggers suddenly, but there are various modes of instabilities that get mixed. It's not one mode that we generally refer to as strain localization, but multiple modes go into mixing with each other, one after another, and then that evolves how the material is going to behave after failure. What we often interpret as failure is actually much later than when failure happened, and that means it has become boundary value problem when we talk about the laboratory test. So in a way, in many cases, the calibration of material models or solving real life problems can be problematic. And this has been a problem for a long time. A number of groups in the world are working on these issues. And some of those examples I'm showing here one by one. It applies to not only landslides that you saw in the first one, but also many cases. A good example of this instability and mixing of modes can be lateral spreading, which is a multi-mode in the sense of liquefaction as well as flow of the material, or you can say displacement of the material with time. So there are other examples of that. So landslides is one, slopes and retaining structures, failure behind them is another one. And then you have liquefaction and its impact on different structures. How do you simulate that in a proper manner? Earthquake faults can be 1 meter, 2 meter, 3 meters sometimes. And they are quite, you can say, narrow band deformations. And their influence on the structure is a lot of interest today. Avalanches, debris flow is what you saw on the slide itself. Pavement cracks in the subgrade is another good example of that. Simulating that is a challenge always. Borehole instability in oil sector has been a topic of discussion for a long time. So these are some examples. There are many more examples where large deformations and cracks and discontinuities can become a challenge and in simulation, and how do we handle those. So as I was mentioning, there are multiple modes. Some of the modes are given here. Bulging of the samples that you see here. Maybe I'll pull up the pen, laser point. Right. this kind of thing you may have seen. Buckling of the samples can happen. And then shear band and strain localization is what most commonly or most researched topic nowadays. Liquefaction is more researched from the applied side right now, but from the science soil mechanics side, there's a lot of unknowns still in that area. So these are some of the modes, and there are many more modes that you can talk about. Some examples are shown here. All these modes go into deformation response of a real life structure. If you want to simulate that properly, then you have to understand those. Why is this so complicated, or why do we need to worry about this? A little bit of glimpse of that is given here. That the soil can behave like a liquid here on the top left, and you saw in the landslide itself, it was flowing like a liquid almost, right? And on the right side, you see a sandcastle, which is more like a solid, but very fragile, less of deformations, you can say, yes, strength in there, with less confinement. It can also behave like a gas that you see at the bottom, for example. And when you have failures, you have some of that in various forms. When we look at an element in a problem, boundary problem, or like, for example, here, soil below foundation, if I look at very small zone and assume that as a single element, then in that, the response, what we observe in the lab, that will be expected to be similar, but it may not be actually, right? So if I look at the failures when it happens and look closely into that, then I'm going into the scale of, you can say, a couple of millimeters. And if I go further down, I'll be reaching the scale of particles. And now the dynamics, or the way things happen, will be understood in a different way when we look at the single element versus when we look at a couple of millimeters. Like, for example, here, finite element simulation is showing that there is a lot of heterogeneity that has developed in a local region. And when heterogeneity has developed, can I interpret that as the strength we measure from the sensors at the top and the cell pressure? Not really. The stresses at the local locations will be very different. And the fluid flow may happen there as well, as densities are changing. So that means under undrained condition also, when we assume there is no flow of water, actually there is a flow of water, but it is local. And as you can see on the particle scale, that is possible as well, because as the particles deform, they collapse, they form new blocks, and the water will be moving locally from one zone to another zone. And all that becomes a complex phenomena where we can look at it more closely with DEM type simulations, discrete element modeling, but that is expensive business. Real life problem solving with that is going to be very challenging. So in that case, we want a solution at continuum level where we can still analyze and solve these problems, these issues, or incorporate these aspects into the behavioral response or prediction of the response for boundary valley problems. So in a way, the combination of continuum elastoplastic framework with some, you can say, element type testing or boundary valley problem, either of those, and the knowledge that we gain from discontinuum granular framework, discrete element modeling kind of concepts, and also variety of experiments that we can do with the understanding of different stress paths and different combinations of stresses, how they impact on the overall response. That is going to connect these two, discrete element and continuum as well. With image analysis, that becomes a little bit more possible to have deformation field measurements and understand how the deformations or the failures are evolving in different zones of the structure or soil element. So with this, you can say different domains of investigation, we have been trying to investigate how to get this problem to a level where we can easily implement in a software where we can have boundary valley problems solved with realistic failure mechanisms. So that is the overall objective of this overall research. What we have recently done is developed a plane strain system, which is with flexible boundaries. And we got some tests done from that. And at the same time, or rather before that, we started working on some, you can say, simulations of plane strain problems. So most of the geotechnical problems are plane strain, we know. And it's easier to look at these problems in 2-dimensional than 3-dimensional. So that is where the motivation was to first focus on plane strain problems. So we did some with Maushmi's effort initially, and then Deban did a lot of work on that. We looked at different mathematical formulations, constitutive equations, how we can predict the bifurcation, using the bifurcation method, you can say how we can predict what happens with different modes of failure. Or instability, you can say. So, and when we do simulation, how these things are going to impact our simulations. So the simulations we are doing today, and we assume that they are correct, are they really correct? That is the question. So we looked at different undrained as well as drained modes with the liquefaction and localized instabilities and so on. If you look here, the only thing I want to point out here is you look these triangles and these circles. So if I do kind of, you can say, large deformation analysis versus small deformation analysis, the formulation that we use in finite element codes. So when we do small strain deformation simulation, we will not see these kind of triangular type instability modes. What we eventually see is only these circles. So that's where the failure appears to be in this as predicted by the response. But actually the instabilities can start well before that. And another point to note here is instabilities start in hardening zone itself. So quite often we say that when you see softening, there is an instability. But actually that is not necessarily true. And why is it important? The moment these things, these instabilities develop, you will have heterogeneous element response, or you can say heterogeneities have developed. So a single element will still behave as a homogeneous response, but actually it may have already caused problems. And that creates mesh dependency. And that is where I will show some results further also. So that is the main message from this slide. Beyond that, you can see large deformation response and small strain deformation response. Even the band inclination angle, the shear bands that develop in a simulation of a single element are quite different. And that is where the small strain deformations have to be understood with a pinch of salt, that we have some approximations involved in those. Similar observations we had with undrained instabilities as well, where, however, the solid fluid instability became more prominent, as you can see with the star sign there. These are followed by some other instabilities, like, for example, shear banding. Now, what is solid fluid instability is one of the liquefaction mode, you can say, something like that. So these keep on happening whether they reach another stable state or they continue to become unstable. And that is where the question is. So if you look here, in some of the cases, it is going to higher and higher level of stresses in this stress path, whereas in another case, it is going to soft location, what you understand as a liquefaction. So, but instability had been triggered in all of them. But some after instability gone into the you can say more of dilative mode, and some of those got into contractive mode and failed. So we also did some coupled analysis of coupled transient analysis, understanding that when we model the fluid flow within the element, then we will have you can say locally drained but globally undrained condition. And in that, the triggering of instabilities is possible, some of the modes, or you can say it is earlier than what you generally observe in other simulations. So one message that comes from here, if you want to simulate instabilities properly, and especially under undrained conditions, then it is better to do transient analysis than the you can say steady state type regular analysis that we do at small strain formulation. So that was one key finding from that. Another aspect is way of triggering instabilities into the soil domain is introducing some kind of property perturbation. So material properties varying from location to location. And that is the reality in the field as well. So when we look at that, what we saw is two things. One is intensity of perturbation has some impact, and there is a way we have to worry about it, and there is a way to handle that also. And second aspect is when you have these instabilities evolving, there will be mesh dependency. So when we look at the mesh dependency while doing FEM simulations and convergence, we generally focus on this region at the lower, but not so much at failure, assuming that failure will be okay. But actually, it is not true. So when we have instabilities, actually it can be predicted at any level, depending on what is the mesh size that you're using. And that is now known as a pathological mesh dependency of small or large deformation. Both have this problem. One solution to that can be that we use rate-dependent models. So rate-dependent models has a time scale captured in that, and that helps in, you can say, handling this mesh dependency issue. Another is you do mesh convergence for each perturbation simulation that you're doing. So in each case, we have to do mesh convergence. It's not like that I have done once and then I can simulate 10 more problems with that. And with those particular perturbation intensities that we have incorporated for triggering the instabilities. And I'm talking in reference to finite element simulations. Right? So with what you see here is the result of that in a way that there can be contractive and dilative bands developing in the soil element if you simulate. And also, you can say, if you notice, a sudden change in the response is observed when such kind of instabilities develop in the global response. So the measurements at the boundaries. And all this is possible when we do transient type analysis and not steady state type analysis, what we 99.9% problems we solve. And with, we have to assume that it is locally drained and globally. So these are some keywords that you have to keep in mind. What it shows is instability developed, then there is a flow of water all around, fluid is flowing internally, but globally there is no flow. So we developed a rate-dependent model also, which is recently published, and with that we did some simulations as well. With those simulations, the results come out to be much better than what we can generally expect. Even if the material as such is not expected to be rate-dependent or not expected to be, the problem is not expected to be rate-dependent as such. Still, for simulation purpose itself, it becomes important to use rate-dependent models if you're doing finite element simulations to capture the instabilities properly. So in a way, what we want to say is this discontinuum world is the way to go, but for only research. When we go to the real life problems, it is difficult, but insights from grain scale analysis is very useful. This is the setup we developed here at IIT Gandhinagar, which is a true coaxial system and all fabricated here itself, and with plane strain arrangement, you can say, if you see a glass plate at the top. So we compared the results from discrete element simulations from Devine's work with the experiments from this plane strain device with flexible boundary, and we found quite a comparable results. These are some of the observations and results from the analysis. This is the last slide, so there is some, I'm finishing in time. So what message I want to give here is simulating instabilities, understanding different modes, and you can say solving real life problems with you can say more realistic simulation of at failure locations with some examples that I gave in the beginning is challenging. efforts are being made at micro level to continuum level to applying that to field problems in all that sectors, and the research is on right now. I'm hoping that with a lot of effort that we are making and several other groups are making, we'll be able to have much better solutions in the future. So with that, I'm stopping it. Hopefully, you have got the sense of what we are doing, a glimpse of that, and I'm happy to take any questions.
Thanks, Professor Amit Prashant, for your presentation. So it's very nice to hear from you. And so for the audience, I think as chairman is yet to arrive, so I thought it's my duty to introduce him properly. So he has completed with the stipulated time, so we have enough time. So maybe I can just give a brief intro to the Amit Prashant.
Dr. Rajesh.
Yeah.
Dr. Rajesh, one more thing which I have forgotten, organizers have informed me. In the papers which are going to be presented today, you have to recommend two best papers for award.
Sure.
Dr. Rajesh.
Yeah. Okay, sir. So I will. We can discuss with Professor Chan Goshen also.
Yes.
Yeah. So Dr. Amit Prashant is a professor of civil engineering and dean of research and development at IIT Gandhinagar. He is currently chairman of the Ahmedabad chapter of IGS and also a member of both governors of SVNIT Surat. So he has completed his BTech from IIT Roorkee in 1997. After 2 years of consulting service, he went for a higher studies at Clarkson University, New York, and then to University of Tennessee. After completing his doctoral studies and 1 year of postdoctoral research, he worked at IIT Kanpur as assistant professor during 2005 to 2010, and then moved to IIT Gandhinagar in 2010. So he has been actively involved in academic administration for 6 years as Dean Academic Affairs before the current tenure of Dean of R&D at IIT Gandhinagar. So with that experience, he was also appointed as an officiating director of IIT Gandhinagar during July to September 2019. So his research interest, just you have seen how very nice works he is doing. So his research work includes the constitutive modeling of soils, earthquake geotechnical engineering, and applications of geosynthetics, which includes the experimental investigation and numerical modeling. So he has done several field-related studies, like projects on hill slopes, excavation, ash dye, bridge foundation, name a few, right? So he is expertise in all these geostructures. He has conducted several industrial courses in electrical engineering, FEM, and geotechnical investigations, which has become very popular. And he's following the footsteps of Udit Jain and N.C. Murthy. He is a very popular speaker, as you have seen. He is also coordinating a faculty development program for last 6 years under the aegis of EQIP scheme of Government of India for engineering colleges in countries. Right? Or people who have joined a bit late. So Professor Amit Prashant has presented a very interesting study on the investigation of instabilities in granular media and the numerical simulation. He has shown how the instability in sand occurs across the different length scale, which need to be considered in different approaches, like continuum, discrete, and then a laboratory-based element test. Right? It's very nice to see this research team has explored the influence of load boundary conditions and then various signatures of local non-uniformities using the image analysis. So he is expert in this field. And then he has also developed two triaxial, which we came to know recently. And thank you so much for the wonderful work and then for the nice presentation. We are eager to hear more from your research team. So can we move to the general papers presentations? So if session coordinator allows, then we can move to the paper presentation.
I think you can actually, as per the rules which are given by the organizers, Dr. Rajesh, I think please start the presentations.
Okay. So for this theme number 9, numerical and physical modeling, we have the 14 papers which is listed here. So may I request the participants or the authors who are planning to give their presentation can write the theme numbers or the paper number on the chat box, so that we are sure that it's like attendance, as well as so we will know exactly who are present in the session. To start with, let's have the first paper, which need to be presented by Rajeshwari, Teja, and Kalyan Kumar. The topic of the presentation is numerical analysis of laterally loaded piles near sloping ground. So, Rajeshwari, if you are here, you can share your screen, and then you will be given 5 to 6 minutes, which includes the question answer session during the period. So try to be on time so that it will be better for the other speakers as well. The paper number 2.
Yes, sir. Sir, myself, Teja, sir.
Teja, yeah, please.
Hope you can see my screen.
Yeah, it's this way.
Very good evening to one and all. Myself, Teja. So today, the title of my presentation is Numerical Analysis of Lateral Loaded Piles Near Sloping Ground. This work has been performed under the guidance of Dr. G. Kalyan Kumar. So these are the contents of my presentation, starting with introduction, need for study, methodology, results, conclusion, and followed by the references. So coming to the introduction part, we all know that lateral loaded piles are mainly used for the support of bridge abutments, retaining walls, embankments, natural slopes, and offshore structures. So whenever these structures are resting on these piles, it is expected that 20% of the design vertical load is expected in the form of horizontal or lateral loads. And it is known that a lateral loaded piles derives its capacity through the soil pile system, and basically this soil pile system is very non-linear in nature, and the performance of this soil pile system depends upon soil properties, material, diameter of the pile, type of loading, and bed slope of the ground. So right now we are focusing on this bed slope of the ground. As we can see in the picture that is here, so in case of a lateral loaded pile, the resistance to the lateral load is derived from passive soil wedge, which is in the direction of the load. And here, as we can see in the figure, that the size of the wedge is going to be decreased in case of a sloping ground when it is compared with flat grounds. So this problem is being addressed here. So in coastal regions, the terrain of the ground is mostly expected to be made of the slope, and these piles that are embedded on the slopes are subjected to both axial and lateral loads. So whatever the mechanisms we have according to IS codes or others, they are applicable only in case of piles embedded in case of horizontal ground. And it is observed that field studies on these proves to be a little highly uneconomical and a little costly affair. Hence, numerical modeling can be considered as one of the economical way to analyze the response of these piles which are embedded on the sloping grounds. So that is why an attempt has been made to investigate the effect of ground slope on the behavior of the piles. So coming to the methodology, so the first figure that is shown here, it indicates the schematic diagram of which the piles that are located on this slope. So the test piles are located at the edge of the slope. Based on various previous numerical studies, it has been observed that the piles that are located at this position are found to be more vulnerable and at highly risky area. So that is why this position of the piles is considered for the analysis. And the parametric study that is being considered is the pile diameter is varied from 0.15 meter to 1 meters, and with the length of the pile of 10 meters and pile cap thickness of 0.2. And coming to the pile group configurations, single pile and 3x3 pile groups are considered. And in case of 3x3 pile group, the pile group spacing is maintained at 3D, 5D, and 7D, where it is the diameter of the pile. And as we have mentioned, our focus is on the slope. So the slope is varied from 0, that is horizontal ground, to 1 vertical to 5 horizontal. And This is the soil strata that is considered. This soil strata is obtained from a local borehole data, which is used for the current analysis. And this numerical modeling is performed in Plaxis 3D software. So the Plaxis 3D software is validated with the experimental work that is performed by Rathod et al. At NIT Trichy. So their work is related to performance behavior of a lateral loaded single pile located on the sloping ground. So the same work is considered for the validation purpose. The load versus pile head deflection curves are obtained from the work, and the same are simulated, and the load versus deflection curves are plotted by using the Plaxis 3D. It is observed that the deviation is considerably less at all the stages of the loading, and hence Plaxis 3D is being used for the further works. So the first figure shows the diagram or the Plaxis model, which is being simulated. So the test pile is located at the edge of the slope, and lateral load is applied in this direction. So here we can see that the lateral load capacity is considered corresponding to a pile head deflection of 0.1 D, that is 10% of the pile diameter. So and here as the slope is increasing from horizontal to 1 vertical to 2 horizontal, the load is being decreased from 25 kilonewtons to 15 kilonewtons. Hence, with the change in the slope from horizontal to 1 vertical to 2 horizontal, 40% decrement is observed in the lateral load capacity. And also at all the stages of the load increments, the pile head deflection is higher in case of piles that are located on 1 vertical to 2 horizontal. And in order to study the combined effect of slope and diameter, these plots are being generated, and it is observed that for a pile of 0.15 meter diameter, the variation or the increment in the slope, the increment in the lateral load is very less, whereas coming to the pile of 1 meter diameter, the decrease in the magnitude of the load is higher when the slope is increasing from 0 degrees to 1 vertical to 2 horizontal. Hence, it is observed that the magnitude of variation is greater for 1 meter diameter pile than 0.15 diameter pile. And this shows the dependence of lateral load capacity on the diameter of the pile. So then the work is being extended to 3x3 pile groups with spacing of 3D, 5D, and 7D. So it is observed that at all the stages of loading, as the load is increasing, the pile head deflection is more in case of 3D spacing, whereas it is less in the case of 7D spacing. This is mainly due to the reduced overlapping zones, which is leading to increase in the load capacity. So in order to calculate the efficiency of these pile groups, this formula is being used. So, and the pile group efficiency is by being calculated for all the pile groups that are considered. So it is observed that for a considered spacing, with the increase in the slope, the efficiency is going to be decreased, and for a considered slope, with the increase in the spacing, the efficiency is going to increase. So in case of horizontal slope, the piles are able to achieve, and the pile groups are able to attain an efficiency of 100%, whereas in case of horizontal sloping grounds, the maximum efficiency that can be obtained is less than 90%. So that is why, so this is from these studies, these are the conclusions that can be obtained. So with the increase in the slope from horizontal to 1 vertical to 2 horizontal, the lateral load that is carried by the pile is decreased by 40%. And as the diameter of the pile is increasing, the load capacity is found to be significantly increasing, even in case of the sloping conditions. And as the spacing is increasing from 3D to 7D, so the effect of the slope is decreasing due to the formation of the passive wedge and decrease in the shadowing effect. And these are my references. Thank you, sir, for giving me this opportunity.
Thanks, Mr. Teja, for nice presentation. So, if there are any questions, can take one or two, or maybe you can write it in the chat box, and then we can always do that. So we will move to the next paper. The next paper by Rishabh Tiwari and Singh UP, UK. and the development of equivalent lattice beam model for support system in tunnels and cavions using FEM analysis. So over to Rishabh Tiwari and Singh. So you will be given 5 minutes time. Professor Chandan Ghosh has come, so he is the chairman of the session. So maybe I request to take over from.
Continue. Okay.
Mr. Chandan Ghosh, good afternoon.
Yeah, please. Yeah. Okay.
With your permission, we have started the session.
Please. Yes. Most welcome.
I think the second paper presentation is going on. Theme presentation happened actually.
Okay.
Yeah.
Yeah. So Rishabh Tiwari and Singh UP, you can share your screen and.
Hello. Yes, sir. Is my screen visible?
It is visible, Rishabh. Only put it on the slideshow. I think you are doing from mobile, I think.
Yes, sir, actually.
Can you put it on the slideshow? Initially we have seen and now we have lost.
Yes, actually I changed the mode, that's why.
Yeah. Now put the full screen mode. Yeah, a little bit increase. Yeah, I think it is inclined. Put it horizontal. We were not knowing that we can do like this also.
Yeah.
Can you increase the size, Rishabh Tiwari?
Yes, sir, I'm trying actually. I don't know, it's getting blanked.
Okay, you can start maybe. I think.
Yeah, this.
Okay.
Okay.
Please start.
Okay, sir. Okay, sorry for wasting such time. My name is Rishabh Tiwari. Topic of my presentation is development of equivalent lattice beam model for support system in tunnels and cavern using FEM analysis. So as you all know, that in weak rocks for tunnels and cavern, we use lattice structured girders. There are 3 bars girder and 4 bar girders. So for analysis of their strength and stability, we have to simulate all the lattice structure, which is very complicated and takes more degree of freedom and number of elements, which makes the analysis larger and takes more time. So the effort was to simulate, develop an equivalent model that can replace that lattice structure and create the same deformation characteristics as that of that original lattice girders. So for that purpose, how we have used some methods and they compared their results, I will be discussing in this presentation. The contents are methodology that are the continuum modeling technique, parallel axis theorem, back analysis using standard formulas, Gergot and Carter method, and direct energy approach, and then finally conclusion. So basically, what I have already described in introduction. Why we are doing this is to develop a computer model to accurately represent a structure mathematically. However, limitations exist that inhibit the ability to achieve the exact mathematical model. One such limitation is the number of nodes, and that the computer model can utilize. For higher number of nodes, we need a higher capable machine to solve our problem. So with this, we will aim to reduce the size of the problem and make the process faster. So this is a typical lattice girder support system shown in the large caverns and tunnels. These are on the roof. You can see these are lattice bars girders. Now, the methodologies are based on basically 3 techniques. First one is to calculate the equivalent stiffness based on the deflection of the loaded lattice girder. Second one is to calculate from the cross-sectional area using the parallel axis theorem. And the third one is to calculate using the strain energy that is stored in these lattice structures due to the applied loading. So in our method one, we will see the parallel axis theorem, which is very basic moment of inertia about its Cg plus area into the perpendicular distance square. This is a simple equation we will use to calculate an equivalent section from that of the lattice girder section. Second method is to use deflection in a lab where we can apply load on a lattice girder, calculate the deflection, and equate it with the standard deflection equations we have, and back calculate the stiffness properties of the beam. The third method is the strain energy based method, which is given by Berder and Cathard. This method has the following steps. First one, to recognize an equivalent isolated repeating cell which will be repeating all over for that entire lattice structure. Then define the displacement field. Then from that, identify the strain parameters for the or for the continuum. Then apply the energy equivalence. Then compute the equivalent parameters. Another method is direct energy approach method, in which this method is also based on the strain energy only. In this method, first you will calculate first you will isolate the repeating cell. Then you will express in terms of the internal forces. Then we will define the displacement field. Then we will identify the strain parameters for the continuum, and then we will apply energy equivalence. Then we will calculate the equivalent beam parameters from that. This is the lattice beam that we equivalent beam that we used in the 3D analysis. Then these are the some geometrical results that we get from all these methods. So we used the two lattice girders, one with configuration 25 mm diameter by 20 by 20 mm diameter, and another one with 35 mm diameter by 25 mm by 25 mm diameter. Both C and D method were based on strain energy. So the difference what we observed while working on them was that in the direct energy method, the varying moment all over the length was assumed, whereas in Cartard method, and it is seen that a constant movement is assumed all over the beam. And also in the direct energy approach, only the longitudinal bars contribute to the axial and the bending stiffness. And in the Bender and Carter method, diagonal and the batten bars also contribute to the axial and bending stiffness. Then finally, I can conclude that the equivalent stiffness of lattice girder are determined by the four continuum models, which are shown in this presentation, which are using these methods. Then interpretation of the result from the analysis has been shown and studied by observing the deflection and bending stresses values of the prototype girder and the FEM model. The equivalent lattice beam can be effectively used as a replacement of a lattice girder having complex structure for the underground space structure. And we have seen that method C and D shows the result second best to the close the result of the numerical analysis. So this is how I will conclude my presentation. Thank you. Any questions? Hello?
So any questions? Very nice presentation by Rishabh. So any questions from the audience? You can drop your questions on the chat box.
Otherwise, they can raise hand also. At the end of the session also, they can ask questions.
Yeah.
Yeah.
Okay, so let's move on to the third paper by Jay Teja and then Anushya, Guha, Ray. Air pressures of soils partially replaced with building derived materials for narrow backfill conditions.
Sir, is my screen visible, sir?
Yes.
Okay. Good evening to one and all. Today I'm here to talk for a few minutes on my topic, which is titled as Earth pressures of soils partially replaced by building derived materials for narrow backfill conditions. And I'm slightly going into introduction.
Jaiteja, sorry. Now it is visible. Okay, please.
Okay. So coming to the introduction and problem statement, this presentation is about how BDM as a material behaves as a backfill soil when it is confined to a limited backfill space. So this problem arises near hill slopes or rock faces, and this narrow backfill condition is defined as when the aspect ratio is less than 0.4, then it is called as a narrow backfill condition, and classical earth pressure theories like Coulombs and Rankines will fail to estimate the pressures when the retaining wall backfill soil is in a narrow or a when it is confined to a limited backfill spaces. And so in this study, I have used three types of materials. One is building derived material, and this is a material which is obtained from segregating construction and demolition waste. Actually, our construction and demolition activities are getting carried out in our campus, and we collected this material from our campus and we crushed down to 10 mm size with a jaw pressure, and it is classified as a poorly graded poorly graded gravel, which contains of 38.2% gravel and 61% of sand, and it is in the range of gravel, and angle of internal friction is resulted to be 46 degrees. And another type of material which we used is red soil, which is a locally available soil which we collected from our campus area, and it is classified as a silty sand, and it is a gap graded soil, and permeability is in the range of sands. And another type of material which we used is river sand, which we collected from Godavari River Basin, and it is classified as a poorly graded sand, and its angle of internal friction is resulted to be 26.5 degrees when we conducted shear box test. And coming to the methodology, we have arranged the materials here in the retaining wall apparatus, and this slide shows the pictorial representation of the retaining wall apparatus, where we have hydraulic jack and retaining wall, and it is hinged at the bottom. And so this particular retaining wall is arranged in a tank which has specifications of 1.2 meter length and 0.92 height, and earth pressure cells are arranged in the backfill side at a heights of 0.2, 0.4 and 0.6 meters, and wall soil interaction is made rough by attaching emery papers on the backside of the wall or backfill side, and bottom surface is also maintained as a rough by including plywood sheet with epoxied with sand. And the boundary conditions of this problem are rigid and non-yielding wall hinged at the bottom, and tank boundaries are fixed and restrained from the movements. So parallelly, we have performed this finite element analysis also. So with the same boundary conditions as we followed or adopted in the physical modeling, with the particular, with these numerical parameters or with these input parameters, and these are the results and discussions. Say when we have conducted a compaction test and we found out that for the red soil blended with BDM and sand blended with BDM, they have reached their optimum content when 20% of BDM is mixed with red soil and sand, and when RBDM and SBDM are arranged in active, at rest and passive conditions, the experimental results which are rendered by the earth pressure cells are higher than compared to Jacques theory, and finite element modeling results are nearly equal to the experimental results in at rest condition. And coming to the active condition, we have compared this our experimental results and finite element modeling results with the Coulombs theory, as the backfill soil is made rough, and the experimental outcomes and finite element result outcomes are lesser in magnitude as than compared with the theoretical values, and active earth pressures are the disturbing forces, as this condition is achieved by rotating the wall away from the backfill, and we can see a deviation in the middle sensor point as the wall is getting deviated from the backfill. And coming to the passive condition, this condition is achieved by rotating the wall about its bottom towards the backfill case. And here we can observe that upper portion or of the upper sensors or the upper points are having more, are showing greater magnitude of earth pressure comparative to lower part of the wall. This is because we have rotated the wall about its bottom base, and these are the peak pressures which we have obtained when we have done a test active and passive test on this physical model and numerical model for both combinations, and the percentage differences for all blends in all cases are less than 30%. And coming to the conclusions, MDD is attained at its peak value by mixing 20% BDM with the soil, and in passive case, a greater value of earth pressure is observed at a upper portion of the wall and decreased with depth, in contrast with the earth pressure theories as we have rotated the wall about its base. And in active condition, earth pressure values are lesser in magnitude comparative to Coulomb's equation. And in a rest case, Jackie's theory has underpredicted the experimental values. And we found out that in narrow backfill case, the magnitude of the earth pressures are more. And if we increase the width of the backfill, the earth pressure magnitudes will be less. And it reduces the probability of rotational failure. And hardened soil model is used in framing the finite element analysis, and it can be used, it can give or it can capture the stresses and displacements that are induced in a backfill soil to a to a good extent. And the difference between numerical and experimental results are in the range of 22%, 20 to 30%, and these are in good agreement with the experimental results. And these are some selected references, and thanking you for giving me this opportunity.
Professor Ghosh, do you want to add?
No, it's okay. I think anybody wants to ask question. I think question answer also you are checking. The question means immediately after presentation.
Anif Cherian raised a hand regarding doubt. Maybe question Anif Cherian.
Okay.
Just see. One Mr. Cherian.
Yeah.
Okay. Cherian, yeah.
So you can you can ask question. Dr. Anil Cherian, if you want to ask question, you can unmute and then you.
Otherwise, we can do it in the end also, Dr. Rajesh.
Okay.
Okay.
Okay, so let's move to the next paper by Vikas and its team. Development of full-scale retaining wall model to evaluate lateral earth pressure reduction using EPS geoform. So it seems to be an interesting study. Dr. Vikas.
Yes, sir. Hello. Hello. Hello.
Yes.
Good evening, sir. Good evening, sir.
Patil sir, you try to share your presentation. We are
yes,
not
I'm
able
just
to
trying to share the presentation.
Yeah, it is coming. Just no problem.
Are you getting the screen, sir?
Yeah, it is showing you are presenting. Yeah. Your screen has come. Now you have to open the presentation. Yeah, make it slideshow. Yes, slideshow.
Yes, sir.
The button. Yes.
So, good evening,
Chairman sir, co-chairman sir, session in charge sir, and all participants and all members who are present today. Sir, we are presenting this development of full-scale retaining wall model to evaluate lateral earth pressure reduction using EPS geoform. The paper aims at presenting an overview of ongoing construction of the model along with required instrumentation setup, as well as discussing the challenges encountered. About the objective of the work is that for field acceptance, field validation of control leading technique, that is the reduction of lateral earth pressure for full-scale retaining wall model is highly essential. And for designing optimum thickness and density of geoform for different heights and different backfill conditions, this is essential. Secondly, the second objective is that to work out or assess the scale effects. Third objective is studying the long-term creep of the geoform. About the model, I can say this is a RCC retaining wall, 6 meter high, 10 meter long. It's a unique one, and we claim that this is the first of its kind where we are testing a full-scale retaining wall for reduction of the lateral pressure. These are the latest some of the distress and failure cases which demand reduction of lateral thrust, and the solution for reduction is what we say that yes, we can introduce EPS geoform. We can place the EPS geoform abutting the retention surface. Thereby, we can reduce the lateral thrust. Then these are the different conditions of earth pressure coefficients. About the literature review, what we can say that, sir, we have considered two cases. One is the static and dynamic cases. Then we consider two types, yielding and non-yielding type of retaining walls, and different tools of analysis, like say numerical modeling, then small scale laboratory modeling, then some mathematical analysis also there. Some of the honorable members or researchers who have contributed in this area, I can name the people, like say Professor Horat, then Karparpu, Bathurst, Trandafer, Etugal, Hazarika, Athanthopoulos, Purnandan and Rajgopal, Dave, Gade, Dasaka, Murli Krishna. About the critical appraisal, about the literature survey and scope of study, I can say that control yielding technique definitely reduces the earth pressure. Then whatever studies available, it is a limited available study having a small scale model analysis. Then present design is having a short-term behavior analysis only, but we required because with the time, definitely the properties of the material, that compressible inclusion, that changes. That's why we need to have a long-term study. Then creep is not also fully understood, so that also needs to be understood. And what is the objective of this particular work is that scale effects, then long-term creep, deformation pattern of retaining wall, distribution of compressive strength in geoform, and preparing the design charts of different density of geoform and thicknesses. This is the field setup which we have established. This is 6 meter high retaining wall, 10 meter long, and the provisions are, this wall is basically designed for rigid, this is a rigid wall, non-yielding, and retaining wall is designed for at-rest condition. The provisions are, we are providing sufficient V-folds. Then there is a geotextile filter is also provided, and shear key is for safety against sliding. About the instrumentation, so there are basically three parameters which we are recording. One is the earth pressure, then tilt of wall, and the last one is the deformation of geoform. And for that earth pressure measurement, we are referring that strain gauges, strain gauge earth pressure sensors, then dual diaphragm pressure sensors, then vibrating wire sensors. So depending based on the limitations which we recorded out of our earlier procurement of say strain gauge pressure sensors from SISCON, we are situated to the vibrating wire sensors, which are giving good results for the full-scale modeling. Then for measurement of tilt of wall, then there is a slope inclinometers which are in process of procurement. And the last one is that deformation of geoform. It is very easy to just measure the deformation in case of say laboratory models by potentiometers or strain gauges. But here in case of full-scale modeling, we are procuring laser-based diaphragm transducer for measurement of deformation of geoform. This is the pattern instrumentation setup where you can see the provision of say holes that is made for pressure sensors and then for recording the deformation of the geoform and even whatever we say that tilt is that just to record the tilt of the wall, there is a provision from the in the stem right from top to bottom. So that is the for incrementers. So this is just general arrangement. About material characterization, sir, for geoform, definitely we have worked out that according to the ASTM D718005 2009, we have worked out the physical properties and some stress and behavior of the that material procured, geoform procured for the study is being analyzed. The servo hydraulic actuator is used for giving the compressive load. About the characterization of backfill material, even though that river sand is a good soil, a good backfill material for the explanation, giving the consistent results. But according to IRC 78/2014, we are following the locally available material, which is good for repetitive testing. And for that purpose, that silty soil, which is there in the campus, Powai campus, that we are using as a backfill material. Even in this context, we are referring some professionals from government departments, public work departments, and consulting them that which material will be good and how to go ahead. Because this is a unique project, and definitely we want that everyone should get participated in the project, in the project as such. That's why we are consulting the the department of professionals to come and just see our work as such. Then in the calibration of earth pressure sensors, as I said earlier, we procured strain gauge pressure sensors from Syscon, and then the calibration of 200 kPa pressure sensor is being mentioned here. About that, dead weight calibration setup was used for calibration, and load is applied using hydraulic actuator. The response of EPS and EPS versus pressure applied by actuator gives a unique voltage pressure relationship for each sensor. But literature reveals that these strain gauge pressure sensors are having limited, say, scope in the evaluation of lateral reduction in the in case of say full-scale modeling. So we have come out with the vibrating wire pressure sensors. They are more, they are more accurate and having a very less aspect ratio, that T by D ratio is less than 0.1, and which is very good for giving the results as such. About the summary, sir, this is just establishment of the model, and what we are dreaming out of this is that to evaluate the scale effect, then long-term creep we want to study, and we want to study the distribution of compressive strength in geoform. We'd like to thank Indian Institute, IIT Bombay, and then MHRD, Government of India, and Savi Infrastructure for giving the infrastructure provisions, infrastructure supports, and financial supports for the project title Design and Development of Advanced Yielding Technique for Static and Dynamic Earth Pressure Reduction on retaining walls using compressible geo inclusions. These are the references. Thank you. Thank you, sir.
Thank you, Mr. Vikas Patel, for your excellent presentation. If there is any questions from audience?
I have a question. Sorry.
Yeah.
Can you hear this time, Dr. Anil? Sorry, it was interrupted last time. I hope, he was talking about the vibrating or strain gauges. Actually, we are using day-to-day construction activities here. You can even refer to the Geocon also. Geocon vibrating wire, that is also good, very reliable. Geocon pressure cells, and if it is possible, you can use some piezometers also, because it's if you are measuring the pressure, you can use the vibrating wire type. So just want to add that one. Nothing else.
Thank you.
Thank you, sir. Thank you for your suggestion. Definitely, we are just procuring this, the information, the intention of presenting this paper over here also, that people should give the feedback, something if you are missing, and if you can do something better, we want to definitely incorporate. Thank you, sir. Thank you very much.
Thank you.
So I have a small query. So you are using EPS geoform, right?
Yes,
so
sir.
what are the properties you are looking at? For
EPS geoform, basically, we want that density of geoform and the thickness. These are the two parameters who are there for the design of the EPS geoform.
Okay.
Density and thickness. These are the two parameters which you are evaluating. So, I mean, based on that, definitely other related parameters we are evaluating, like some physical properties we are recording. Then we are just studying the stress and behavior of the particular geoform.
Yeah, I was thinking modulus is also an important parameter.
Yeah, that is there, sir.
Thank you.
Thank you, sir.
So maybe you can stop sharing your screen and then we can call the next paper presenter.
Thank you, sir.
Vaibhav Chaudhary and then Jitendra Singh Yadav. So they will be presenting a paper on prediction of ultimate bearing capacity of eccentrically inclined loaded strip footing resting over dense and medium dense sand using generalized regression neural network. So over to Vaibhav Chaudhary and his team. Kindly share your screen. Is Vaibhav Chaudhary is here? Jitendra Singh Yadav? Yeah, okay.
Oh, he is also using mobile. Wow.
Hello, good evening, everyone. Is my voice clear?
Yeah.
Voice clear, but screen there.
Okay, screen.
That's much better.
Yes. So my network is not good here, so that's why I'm using mobile.
Okay. Is it a PowerPoint or your?
It's a PowerPoint presentation.
Okay. Okay, proceed.
The same problem is, I think, with me also.
Well, you show that small screen. No problem.
Is it visible now?
Yeah. Continue. Start speaking.
Okay, sir. My topic is prediction of ultimate bearing capacity of eccentrically inclined loaded strip footing resting over dense and medium dense sand using GRN neural network. It is also a type of neural network which helps in prediction. The only difference is that it predicts the output variable in the form of category, and PNN predicts the output in the form of categorical form. My main motive is to predict the output of RF with the help of three inputs: the embedment ratio, and the eccentrically inclined ratio, and the inclination ratio. With the help of these three inputs, I predict the output of RF, which is the ratio of ultimate bearing capacity of eccentrically inclined footing to the ratio of centrically footing with zero inclination. So with the help of RF vector, we can calculate the ultimate bearing capacity of eccentrically inclined loaded strip footing. So I uses the GRN neural network for this prediction work. The main okay, why I use this GRN, as it is much simpler in comparison to ANN network. It is much faster to train GRN model in comparison to ANN model, but it requires more memory space to store the model than ANN model. Okay, this is the literature review. I uses the laboratory model test parameters, 120 data sets for the training purpose. 70% of the data I use for training and 30% I use for the testing purposes. These data sets are taken from the C. Patra work, which he conducted a laboratory model test on a strip footing, eccentrically inclined strip footing. The embedment ratio varies from 0 to 1, eccentricity ratio varies from 0 to 0.15, and inclination ratio varies from 0 to 20 degrees. Okay, I'll come to how does it work. The basic principle of neural network, it needs a training data to train itself, should contain input-output mapping. Output is estimated using weighted average of the outputs of training data set, where the weight is calculated using Euclidean distance between the training data and test data. If the distance is large, then the weight will be very less, and if the distance is small, then it will put more weight to the output. It contains 4 layers. The first one is the input layer, second one is the pattern, then summation, then comes with the output. Okay, pattern layer calculates the Euclidean distance and activation function. Then comes the summation layer, which has 2 neurons, numerator and denominator. Numerator part contains summation of the multiplication of training output data and activation function, while the denominator is the summation of all activation function. At the end, output layer is calculated by dividing the numerator part with the denominator part. So this is the GRNN equation. General equation, di square is the Euclidean distance, where x is the input and y is the output variable. So e to the power minus di square upon 2 sigma square is the activation function, which is used as a weight for each input variable. And now the single parameter which remains is the sigma. This is the spread constant, which can be tuned in the training process to an optimum value where the error will be very small. This part is of the data collection from C. Patra. 120 data sets were used. 70% are taken as training and 30% are taken as testing data. Okay, these are the model test parameters. Dense and medium sand. Unit weight of the soil are 14.36 for dense and 13.97 for this. So these are some parameters like relative density, friction angle, eccentricity ratio, embedment ratio, and the load inclination. Okay, in the next slide, I have shown the different data sets for dense sand and medium dense sand. The 3 input parameters are there, and I have the output parameter is the reduction factor value. So these are the different, these are the 120 data sets that I use for training and testing purposes. So this is the training procedure. In the training procedure, optimum value of sigma is computed, which can be best calculated where the mean square error is minimum. Okay. These are the computations by DTREG. Actually, I use a DTREG software to compute all these for these computations. These are the calculations which I used. For each variable is used, a minimum sigma value is kept as 0.1201, maximum value is kept as 10. And the iterations used were 2500 something iterations were considered. This is the input data computations. And these are the summary of variables. Sand type is the unused variable. Embedment ratio is predicted, as I said. And you can check it from the computations from training data also. We got the correlation between actual and predicted as 0.998, which is nearly linear, which shows high accuracy and precision. Hello? Hello, sir. My voice is coming?
Yes, please proceed. We are hearing.
Okay. Okay. Now, these are the computations for validation data or testing data, which we get the correlation between the actual and predicted is 0.994, which is very linear and accurate, and the errors are also given in this. Mean square error is around 0.000, which is very less, and proportion for variance is also 0.986. So you can see the accuracy of the model. So this is the model of GRNN. This is the input nodes. These are the hidden nodes and the class node and the decision node. Final variable is the output variable, and the input are these three variables. And from this graph, you can see the relative importance of variables, angle of inclination, angle ratio.
I think your time is up. You kindly conclude it.
Okay, these are some graphs. You can see these are the mathematical indices which I used for the comparison of GRN and ANN. And from the graph, you can check the accuracy of the results. And the conclusion is simple that it helps the network to be trained faster, GRN. That's why I use this network. And it is more precise than conventional and traditional networks. And accuracy is more than those conventional networks. It also helps to conserve more time and money in comparison to those traditional conventional methods. So these are the references which I used for this study, these 4 references. And thank you very much for giving me the time. Any questions? Hello?
One question. Yes. Can I ask one question? Sorry.
Yes, sir.
Yeah, please.
Yes. Can I ask one question? Have you considered the distribution of contact stress along the footing base during the analysis? Just want to know because it's have you considered the distribution of contact stress along the footing during the analysis?
Stress.
Just want to. Yes. Well, there is a contact stress distribution of the contact.
Sir, contact stress is not considered as a parameter for this. In the input variable, I have used the three parameters only.
Yeah, so it may be good, but I don't know.
Yes,
you can check with your.
It may be an option also, but from the data sets, this option is not available for this model.
Okay, thank you very much for the nice presentation.
Thank you, sir.
Thanks, Vaibhav. Maybe we will move to the next speaker. So the next one is by Sharmila, Balakumar, and Chandrasekharan. The topic of the presentation is the optimization of file draft on SAN for plaza type structures. Sharmila and his team, are you there?
Yes, sir.
Yeah, kindly share your screen.
Good evening to all. First of all, I thank everyone to give this great opportunity to present in Indian Geotechnical Conference 2020. I'm Sharmila from VIT, Value Institute of Technology. I'm going to present on the topic of optimization of file draft on SAN for plaza type structures. In the fast growth of cities all over the world lead to increase the high-rise and the super-tall structures even in unfavorable subground condition. On that time, the designer had a great challenge to design the foundation element for tall structures that cannot tolerate the settlement and cost of foundation. So it presents the development of tall structures which carry a shallow level structures with less flows there, but they are heavily loaded structures. It is mainly due to car parking facilities and utility element placed on the floors. In a combined foundation, the load coming from the superstructures is partially carried out by piles through the spring friction and partially carried out by raft through contact pressure. Therefore, providing the same parameter of piles for a different loading condition becomes uneconomical. So for a beneficial, the optimization of a pile draft is carried out. literature survey. Extensive work from the literature survey. Extensive work has been done for the pile draft foundation. Some of them are listed here, but very few work has been carried out on the optimization work with the pile draft in the case of structures with a various stiffness. So the study has been carried out. Scope of study. In this study, carry a tall structures on the center of a building, and it can get either side a shallow portion. In this, column load can be varied. Such aspect optimization is done by providing the shorter length of a piles for the shallow portion and longer length of a piles for the tower area. The above condition is repeated by keeping the length constant and diameter is varied. Then the objective of the study carried out so far has been concentrating on the various aspects of a load shared by the piles, settlement behavior on the shorter and longer piles, and finally the raft contact distribution with and without the piles. Then this is the methodology followed for our work. In figure 4 shows that the column layout of the building, and the center of a building carries the 12 stories and either side carries the 4 stories. Then the building is modeled and analyzed in ETAPS, and this image 6 shows that the deformed structure after analysis. After analysis, in ETAPS, after analysis, as per IS 456-2000, the design check has to be carried out so far. Finally, this image shows that every frame element has passed the design check. After the design check, the support reaction obtained from the ETAPS has been taken for the design of a foundation element. Then this is the material and geometrical properties we are applied for the design of foundation element. Then figure 7 shows that the pile layout of the pile layout, in which a pile is exactly placed below the column. Since the building is symmetric with each other, so the pile naming from C1 to C7 has been taken for the plate strain analysis. In the total 7 number of piles, 4 number has been taken for a tower area, and the remaining 3 has been taken from a shallow portion. Due to story height, the loading is different. Here, in a shallow portion, the pile length is varied for 3 cases. One is kept equal for a tower area pile length, and second one is 50% of tower area pile length and 80% of tower area pile length. Then the tower area pile length is kept as a constant of 20 meter. Then the same procedure is kept same procedure is repeated by keeping the length constant, and diameter is varied as 700 mm and 800 mm and 900 mm. The raft thickness for this raft thickness is kept as constant of 900 mm. From this deflection result, we can say that when the length of a pile is kept as 20 meter, the load carrying capacity of a pile at the D/T ratio unity is 15% higher than the D/T ratio of 0.8. When the same ratio is compared for decreasing the shorter pile length of 16 meter, the load carrying capacity is increased by 25%. Then the shorter length of pile was kept at 10 meter. Again, the load carrying capacity is increased by 40% with the D/T ratio of 0.8. Then for this shaft stress distribution, the diameter is kept as constant of 700 mm. The length of shorter pile length is varied as 20 meter, 16 meter and 10 meter. 10 meter. From this result, the shaft stress falls rapidly beyond the pile length. That is, when we use the 16 meter, 14 meter is the effective pile length. At the same time, when we use the 10 meter shorter pile length, 6 meter is the effective pile length. But when we use the equal pile length, the shaft stress curve remains the same. Now the diameter is increased to 800 mm. The length has been length kept as 20 meter, 16 meter and 10 meter. While the length remains the same, the rate of fall of shaft stress appears to be more rapid from the beginning. at the point corresponding to 50%, that is 10 meter pile length, the shaft stress falls by 40%. But at a 16 meter pile length, it can be said that the shaft stress falls between 0.5 to 0.6. Then, when the pile diameter is increased to 900 mm, the shaft stress for even the diameter changes, the shaft stress for equal length of piles remains the same trend. But here, for a greater diameter, the shaft stress falls rapidly beyond the pile length of 0.4 L to 0.6 L for a 10 meter pile, and for a 16 meter pile 0.45 to 0.75 L. The effective pile length will be 0.4 to 0.8 L. Then while changing the pile length, the shaft stress decreases with the decrease of pile length, even the loading is same. The minimum interaction occurs at a shorter pile length when compared with other two cases. That means when we reduce the pile length to 80% and when we use the pile length equal, the interaction value nearly the interaction value varies 68 to 85% while the pile length decreases. At the same time, while comparing the change in diameter, the shaft stress remains same at the top of the pile, but gradually decreases at a certain point of 8 meter. But after that certain point, it gradually increases. From this contact pressure distribution graph, we can clearly shows that the behavior of raft on the pile raft foundation shows that the contact pressure on the raft gradually decreases on the pile location. Finally, I conclude from this study, it is observed that the introduction of pile reduces the settlement in the foundation by 80 to 90% for the present layout. The load carrying capacity of a raft increases with the usage of small length of a pile. Then the more settlement is observed for a small length of a pile. By using a different length of pile, the contact pressure distribution of raft carries 70% of load when compared to the same length of a pile. When in the shallow portion, the shaft stress distribution falls rapidly at a certain point. Even the pile diameter increases and the length of a pile increases. Therefore, instead of changing the diameter, changing the length of pile to be better issue. Thanking you.
Thank you, Sharmila, for nice presentation. So,
finally, I thank you.
Do you have a question to pose? Your hand is raised.
Finally, I thank my guide, Dr. V. Balakumar sir and Dr. S.S. Chandrasekhar sir, who guide me and support me for the study.
Yes. Okay. So I have a small query. Generally, the length of the pile will be decided based on the load carrying capacity, right? So, but one of the conclusion is that you need to increase the length rather than changing the diameter. So, can you just explain what exactly you are trying to say?
So, instead of changing the diameter, changing of pile length is to be better. It gives a better result.
So, this is for any type of soil, because it seems to be a more general conclusion you are taking.
Now, sir, I studied for a medium ring sand.
Okay, thank you. Any other questions? If no more questions, then we can move to the next speaker. So the next paper is by Dinesh, Puran Ray, and then Dasaka Murthy. The topic of the presentation is development of calibration methodology for air pressure cells for installation on full-scale retaining wall. Mr. Dinesh, are you there?
Yes, sir. Is my screen visible?
No.
Dinesh, please share your presentation.
Yes, sir.
Yeah. Now I think it is coming. Just hold on. Yeah, it is coming. Just hold on. Yeah, it has come. Put it for slideshow.
Yes, sir, it is in slideshow.
Okay, please continue.
Okay. Hello all. I'm going to talk about earth pressure cells, and this is a part of full-scale retaining wall project, which was earlier mentioned by Mr. Vikas Patil. And these are the contents which I'm going to cover during my presentation. As we know, earth pressure measurement is the basic measurement in retaining wall, foundation, or tunnel, and the purpose of measurement is of this parameter is so that we can verify the adopted design methodology, we can improve the present design, or we can monitor the structure. Now, for the most common way of obtaining earth pressure is earth pressure cells. These are the types of earth pressure cells, and in this, I am going to talk about stiff pressure cells, and in that also diaphragm type earth pressure cells. So the need of the study is that we are going to conduct a full-scale testing to check the suitability of geofoam as inclusion material, and so for that a retaining wall will be constructed of 6 meter height, which will be fully instrumented, and the major part of that instrumentation is earth pressure cells. So for that, this is a literature review paper. So I'm going to cover the aspects or factors which affect the earth pressure cells, how to properly calibrate them, and what are the recent development in earth pressure cells. So the factors which affect the earth pressure cells are studied by various authors, and I think there is some lag in screen. Okay. Coyle and Bartoskip studied the effect of grout and temperature, and they found that the effect of grout is negligible, but there is shift in zero gauge reading with increase in temperature. And Paleo and Bauer in 1986 used pneumatic earth pressure cells. They performed fluid calibration, soil calibration, and they did concrete interface measurement. They also studied the effect of temperature, contacting material, and installation method. They found that the temperature has a predominant effect, and it plays a major role in earth pressure determination. And the effect of contacting material was not found to be significant. Is my screen visible? Is this changing?
No, Dinesh, your screen is frozen, right? Not moving.
Yeah. I will share again. There is some network issue.
Yeah, now it is visible. Factors affecting EPCs. Okay.
Yes, sir. Yes. So Clayton and Bika performed laboratory calibration, and they give design charts, which is shown here. They defined the term CAF, which is cell action factor, and they correlated its flexibility ratio. Flexibility ratio is defined here with this equation, which involves the soil parameter and the diaphragm, earth pressure diaphragm parameter. So for achieving higher CF value closer to 1 shows an ideal sensor response. So by using this chart, we can choose our sensor. And also, if we are trying to develop our own, then this is very useful. Now, as mentioned earlier, that the contacting material did not play many significant role, but Gade the saga in 2019 found something different, as the use of geofoam is increasing day by day. So it is not essential that the soil will always be a contacting material. So Gade the saga in 2019 studied the effect of geofoam as a contacting material, and they found that the response of earth pressure cells depends on the stress strain behavior of the contacting material. And as you can see here,
so again, it's not working.
Is it working now?
No, still in the same slide. The factors affecting EPH.
Yes, sir, it is same, but slide is.
Yeah. Gadi. Slide number 7.
So, yes, sir. So in this, they found that the stress strain behavior of contacting material affects the response of sensor, and so we need to incorporate that. This table summarizes all the factors which affects the response of sensor and how to incorporate them. So this table is very useful while selecting the sensor. Now, after selection of sensor, the next part is calibration. So calibration, there are two methods: uniaxial calibration device and universal calibration chamber. So these two are shown here. So first one is for checking the uniaxial compression response of sensor, and the second one includes the 3D effect, which will consider the 3D effect. There are two bladers, upper bladder and lower bladder. Upper bladder will transfer the load uniformly, and the lower bladder will measure the quantify the frictional resistance present if there any. The use of this calibration chamber was done by Curus in 2001, and they proposed a method and pocket container method, and they used this method again and check field suitability as well as laboratory suitability. So the sand pocket container is shown here. Watchman and Labus used the universal calibration chamber, and after performing the laboratory test, they performed soil structure interaction model, and they found that there is an over-registration of over 15 to 18%, and same was the case observed by soil analytical model. They also mentioned that change in soil density can change contact stress, and depending on that, the earth pressure cell may also under-register. So we have to take care. There are development also in earth pressure cells, and Chesney et al. In 2014 developed a new soil pressure system, which is known as null soil pressure system, which will discard all the effect of diaphragm deflection and thus the arching effect, and it also does not depend. It will not also be affected by the shear stresses. But the major problem is that the system is.
Sorry to interrupt, Mr. Dinesh. You will have to conclude soon. Yes. Already 8 minutes.
This is last presentation. So the conclusion is that for achieving optimized design, the earth pressure measurement is essential, and for that we are using earth pressure cells. And there are various factors which affect the earth pressure cells. And calibration method, and it is found that the earth pressure cells are generally provided with fluid calibration charts. So we have to develop our own calibration method charts in the laboratory and to simulate it as close as possible to the field. Though there are various improvement in EPC, but the use of traditional EPC is more because of larger user experience and availability of performance records. These are the references which I have referred, and I would like to acknowledge MHRD, KT Bombay, and Survey Infrastructure. Thank you.
Thank you, Dinesh.
Sorry, there
Since
was
time is
lag.
too less, I think we will have to move to the next speaker. So the next, the theme paper number is 23, numerical simulation of field wind shear test using finite element method by Anand and his team. Kindly share your presentation. Yes, Mr. Anand, you can start now. I think I am unable to hear. So what about the audience? Can you hear this presentation?
No.
No, we're not able to hear.
I think he's muted the mic. He can unmute the mic.
Oh, okay. Sorry, sir. Sorry. Okay. Okay. Am I audible now? Sorry.
Yeah.
Okay. Good evening, one and all. Fine. So this is a title of my presentation, numerical simulation of wind shear test using FEM. And as we know that wind shear test is used both in lab and field for getting undrained shear strength of the soil. So which can be also modeled in Plaxis by using finite element method. And this is the work which was carried out by one of my student, and on his behalf I'll be presenting this work. And basically these are some parameters which we have considered as standard dimensions which we have considered as per ASTM standards. And in Plaxis 3D, we have modeled this, and height to diameter ratio, we have kept it around 2. And basically, we have done some sensitivity analysis by changing the thickness of the blade so that we can see how does the thickness of the blade is going to affect the shear strength of the soil, undrained shear strength of the soil. So to see that, we have changed that particular parameter by keeping other parameters of the soil as same. And these are some properties of the soils which we have considered. And here, basically, we wanted to see, like, if I consider more cooler properties and maybe hardening soil model properties, then what will be the difference in the values or difference in the results what we get. And we have considered two types of soil, since we know that we use wind shear test in a very soft clays, very sensitive clays. So that's the reason, one of the main reason we have considered the soft clay. And the other extreme part of that, we have considered the stiff clay, just to see the difference in the results what we get. And as I said, we have considered two different types of material models. One is MC and other one is hardening soil model. And this is something about the boundary conditions what we have considered. In the top surface, we have kept it free, and where the bottom part of the blade is fixed in all three directions, in X, Y, and Z directions. And to simulate the torque, okay, so we have introduced the line loads along the vein blades, so that the torque will be introduced, and the results will be, we get the results, something like that. So, and these are the boundary conditions which we have given for the cylindric specimen of the soil. So some boundary conditions have been given for this. And I'll be showing a few results of this. Of course, this is just some part of the work which I'll be discussing here. Like as we see from this particular figure, so around 11.9% of the total load what we had applied, the line load what we had applied, that was around 25 kN per meter. Only 11.9% of the primary load has been achieved. So the failure has been taken place up to that particular load. And it was also observed that the torque at the failure, especially for stiff clay obtained from Plexus simulation via hardening soil model and the Moore Coulomb model, were a little difference was there. And particularly these calculations were compared with the conventional method. So with the conventional method, with the theoretical calculations, most of the values which we got from the hardening soil model were well in agreement. So that is what we actually observed. And also, we also see the change in perimeter ratio. So we can define the perimeter ratio like this. It's a thickness of the blade by 4 times of the thickness of the blade by pi d. So where d is the diameter of the the total diameter of the blade. So this is how we get the perimeter ratio, and the perimeter ratio has been observed with respect to the different undrained shear strength values. And we observed that basically all these 4 simulations, they show that undrained shear strength values are basically, they are inversely proportional to the perimeter ratio. And also it has been also observed in few literatures carried out as a part of experimental research in Kerato 2004 and Terzaghi 1996. And as a result, one more thing we observed that when different blade thicknesses were used, the undrained shear strength varied very significantly. So even the thickness of the blade had a very huge influence on the undrained shear strength values. And we just tried to analyze the plastic points which developed at different planes. So we had taken 3 planes, one top, bottom, and middle plane, A, B, C, and we observed the plastic points which were developed near the soil. So those things also we observed, and it was also observed that at the top there was a very dense accumulation of plastic points. So from the results actually of both soft clay and stiff clay, Moore Coulomb modeling shows the larger torque at the failure. And these results of 4 simulations with the same soil and different blade thickness. So it showed us the different undrained shear strength values. And as I said it already, it's inversely proportional to the perimeter ratio. So the undrained shear strength, because it's inversely proportional to the diameter. So as we know, and the plastic points were more emphasized at the top than the middle of the device. So thank you everyone for giving this opportunity. So these are my references. Thank you.
Thanks, Mr. Anand, for a wonderful presentation. So
Thank
due
you,
to shortage of the time, I think we will have to move to the next speaker.
Okay,
Otherwise, we will be missing the cultural event.
Okay, sir.
So the next speaker is Rajesh Khanna and Chitra. The topic of the presentation is comparison of flow nets for varying thickness of vertical core earth and rock fill dam under rapid drawdown and steady state seepage, and its effect on the stability of the numerical modeling. So you may start. Yes. You can make slideshow.
Is it visible, sir?
Yeah. Please.
Okay, good morning. Good evening to one and all. So, sir, I'm Dr. Rajesh from CSMRS New Delhi, and the topic of my presentation is comparison of flow nets for varying thickness of vertical core earthen rockfill dam under steady state seepage and rapid drawdown, and also its effects on stability using numerical modeling. So stability of an earthen rockfill dam under steady state seepage and rapid drawdown conditions largely depends on the flow net generated in the core of the dam, in the direction of the flow lines in flow direction or in the reverse direction of flow in core may destabilize the factor of safety. So in my present paper, I have generated flow nets for the varying thicknesses of the core from thin to thick core. So outline of my presentation is introduction, literature review, objective and results of flow nets and stability analysis of earthen rockfill dam. I have used slide software for vertical core. So then discussion and results, and then conclusions. So background stability of an earthen rockfill dam mainly depends upon the geometry and the components. For example, it may be it is a zone dam, and the material properties of the shell and the core and the forces to which it is subjected. The shell of the dam enhances the stability and the core enhances its imperviousness. The primary objective of my presentation is to compare the variation in flow nets and the steady state seepage and rapid drawdown in the core of dam on account of variation in thickness of the core. Further, the sub-objective of my presentation is identification of influence of different thicknesses of vertical core on the stability of dam slopes for upstream slope and downstream slope due to variation in flow net condition under steady state seepage and rapid drawdown conditions. Now, from the literature, it is found that the minimum thickness observed to be 17% of the height of the dam and maximum thickness reported to be 200% of the dam, and this has been taken from various literature. And also the strength parameter of the shell material in most of the cases is from 35 to 45 degree. And the strength properties of the core is cohesion intercept is 20 kPa to 50 kPa and 14 to 25 14 to 25 degree respectively. Now, in my analysis, I have chosen a dam section of an earthen rockfill dam of height 180 meter, and I have chosen upstream slope of the dam 1 vertical to 2.7 horizontal, and downstream slope of the dam is 1 vertical to 1.90 horizontal. So this is a simplified section of an earthen rockfill dam under steady state seepage. So I have chosen a dam section under full reservoir condition. These are the upstream and downstream slopes of the dam, and this core thickness has been varied. This is a simplified section for earthen rockfill dam under rapid drawdown condition. I have chosen the rapid drawdown for h/2. That means it is a half drawdown level is half of the height of the dam. Now, strength parameter of the shell has been taken as for steady state seepage has been taken as C is 0 kP and effective angle of shearing resistance 42 degree. And for rapid drawdown condition and for rapid drawdown condition, C prime is 0 and phi is 24 degree. The choice of parameter and range. Now the vertical core has been varied from 1 vertical to 2.5 horizontal to 1 vertical to 2.7 horizontal, an increment of 0.25 h. And for each increment of the core, the variation in flow nets has been observed in steady state seepage and rapid drawdown condition. This is how the variation of the core has been done for various thicknesses of the core. Now for the rapid drawdown condition, drawdown level is adopted as h/2, where h is the total height of the dam. Now results. Now we have compared the flow nets conditions and the variation of core thickness under steady state seepage and rapid drawdown condition. So this is a thin core. This is a steady state seepage condition under full reservoir, and this is a rapid drawdown condition. Now we observed in this the flow lines in steady state seepage are towards the downstream slope of the core. This is core only, and the flow net in the flow lines in the rapid drawdown condition, some of the flow lines are towards the upstream slope and most of the lines are towards the downstream slope. Now, as we increase the thickness of the core, most of the flow lines in the steady state seepage or magnitude of the flow lines towards the downstream slope of the core increases, and also in the rapid drawdown condition, the magnitude of the flow lines increases towards the upstream slope. So as we increase the thickness, magnitude of the flow lines increases in respective cases. Now after doing this, we have done the we have done the stability analysis of the dam to find out at what thickness the core would be critical. The thickness of the core would be critical. So the effect of flow net on stability analysis and the influence of core thickness under steady state seepage has been carried out. Now under steady state seepage, the downstream slope of the dam is critical. So stability analysis for the downstream slope has been carried out. Now this is a stability analysis for the thin core, and we found that the slip circle passes through the shell and the factor of safety is 1.71. Now as we increase the thickness of the core, the factor of safety is 1.71 and the slip circle still passes through the shell. Now, as soon as the thickness of the core is increased, the effect of core comes into account and the factor of safety decreases, that is 1.65. So, because of the development of the pore water pressure. Similarly, the graph has been plotted between the factor of safety and the thickness of the core. Now, in this graph, we observed that for a thickness of the core, for 100% core thickness of the core, for the height of the dam, the factor of safety is constant. But after this, the factor of safety decreases and it continues to decrease till the upstream and downstream slope of the core merges with the upstream and downstream slope of the dam. Similarly, we have carried out the stability analysis for dam under rapid drawdown condition. Here also, this analysis has been done for thin core and the slip circle passes through the shell. So factor of safety is 2.45. As we increase the thickness, it is still passing through the shell. But as we increase further the thickness of the core, it passes through the core, and due to development of pore water pressure, the factor of safety decreases. Similarly, the graph has been plotted between factor of safety and thickness of the core. Here we see when the factor of safety is constant up to the thickness of 150% half height of the dam, and then it decreases continuously as the thickness of the core increases. So these are the critical thicknesses under steady state seepage and rapid drawdown. So from the flow net, it is observed that the thickness of the core is critical for a particular dam section. So discussion for downstream slope of the dam under steady state seepage condition, there is no change in factor of safety as long as the 0.125 horizontal to 1 vertical to 0.50 h or 100% of the thickness of the core. Because the slip circle passes through the shell and it is highly pervious and there is no development of pore water pressure in the core material because the slip circle is not passing through the core. But beyond this, beyond upstream and downstream slope, the core slope is 1 vertical to 0.5 horizontal. The factor of safety decreases because the slip circle passes through the core and there is a development of pore water pressure. As the thickness of the core increases, the magnitude of flow lines increases towards downstream slope of the dam and thus further decreases the factor of safety due to development of pore water pressure till the downstream slope and upstream slope of vertical core merges with the outer slopes of dam. Similarly, in the rapid drawdown condition, it is observed for upstream slope of dam under rapid drawdown condition as the core thickness is such that the vertical core of slope is steeper than 1 vertical to 0.75 vertical. There is no influence of core on the stability of the slope of dam because the slip circle passes through the shell. It is highly pervious. And beyond this, the slip circle passes through the core. Because of that, there is a dissipation of pore water pressure, and thus factor of safety decreases as the magnitude of flow lines are towards the upstream slope of the dam. So, as the thickness of core further increases, the magnitude of flow lines in the reverse direction, such that towards upstream slope increases and factor of safety continue to decrease till the upstream slope of core merges with the upstream slope of dam.
Dr. Rajesh Khanna, sir, so maybe your time is up. It's close to 9 minutes. Maybe you can conclude.
Factor of safety under steady state seepage and rapid drawdown condition depends upon the magnitude and direction of the flow lines, and also after critical thickness of core under steady state seepage and rapid drawdown condition. When slip circle passes through the core and factor of safety decreases and continue to decrease till the upstream slope and downstream slope of the core merges with the upstream slope and downstream slope of the dam due to development of pore water pressure. So these are my references. Thank you.
Thank you so much, sir, for an excellent presentation. So, is there any questions? It's a very nice work. Somebody has some questions. Okay, so if somebody has a question, they can always write it in the chat box. So thanks, Dr. Rajesh Khanna, for your nice work.
Thank you, sir.
Then let's move to the next speaker. So the paper number is 28, the numerical analysis of bearing capacity and settlement reduction of bamboo reinforced sand beds by Ajay Shankar, Akhil Shankar and Chandrasekharan. Rajesh is there?
Yes, sir. Yes, sir. Hello? Hello?
Yeah. Really, you can share your screen and then you can start presenting.
Sir, visible, sir? Hello?
Mr. Rajesh, kindly share your screen and then start presenting. We're running out of time.
Visible, sir. Good afternoon, everyone. My name is Rajesh Shankar, and my topic is the numerical analysis of bearing capacity and settlement reduction of bamboo reinforced sand beds. A brief introduction about the topic. As we all know, the rapid growth of industrialization and destination demand more ideal land to meet the requirements. So, construction in loose soil becomes unavoidable. In such cases, soil needs to be improved to increase its mass density as well as bearing capacity. So, reinforcing soil with locally available materials are very cost effective and hence widely practiced nowadays. Out of these materials available, bamboo is one of the most effectively bamboo is one of the material which has excellent mechanical properties to meet this purpose. A wide variety of bamboo are available across the Western Ghats as well as across the country. So coming to this particular topic, numerical modeling, these FEM methods are really useful in analyzing the problems having complex geometries. Flaxus QD is one of the robust finite element software to do the same. The study aims to numerically compare the effect of thickness of the reinforcing material of a sand bed. The objective of the study is to numerically model the bamboo mat reinforced sand bed and study the effect of reinforcement layers on the bearing capacity of the sand bed. These are the literatures that referred for the study. Coming to the experimental program, the pre-code test was conducted to study the behavior of sand beds in both reinforced and unreinforced conditions. The code used was IS 1888-1982. The tank size was 750 by 750 by 750 mm, and the footing size was 150 by 150 by 25. And the relative density of sand was 60%.
And coming to the numerical modeling, this same dimensions of the tank were used in the numerical modeling, but only a quarter portion of the tank was modeled since to avoid the complexity of the calculations. But the model has to be a circular one to analyze an axisymmetric model. So when the journals referred, I found that only 2% variations from the results obtained from a model of rectangular cross section with the same area we can use. So we can only 2% difference was observed. So we can use it as a circular model of same area. The boundary conditions were fixed as that the horizontal boundaries, which represents the vertical walls of the test tank, were restrained on horizontal direction, while the bottom boundaries was restrained in both vertical and horizontal directions. These are the inputs of the study for the soil properties, which are input. The material model used was Moore-Coulomb model. Moore-Coulomb model is the most appropriate model for this analysis of sand, since it uses all the elastic and inelastic parameters of the soil. Drainage type was strained, and Young's modulus was 3,500 kilopascal, and the Poisson's ratio 0.3. And we have to include a small value of cohesion to prevent the premature soil leading in the locally low containing pressure zones and to account for possible additional apparent cohesion due to the moisture in the backfill. So a small value of cohesion had to be given, that is 1 kilopascal, and angle of internal friction was 39.5 degrees. And we had to enter the dilation angle value for the sand. In theory, the value of dilation angle for dense sand is around 15 degrees, but for the modeling purpose, we have to use 2/3 of the value of the angle of internal friction, that is 28 degrees. And the depth first reinforcement layer was kept as 0.3 times the width of the footing. The width of the bamboo mat was kept 3 times the width of the footing. Subsequent layers were kept at 0.3 times width of each footing. The number of reinforcement layers was increased from 1 to 5. Up to 5 number of reinforcement layers were analyzed, and a uniformly distributed load was applied on top of the footing. And to study the behavior, a non-dimensional parameter was introduced to evaluate the degree of improvement of bearing capacity. That's improvement factor, which is the ratio of bearing capacity of unreinforced bearing capacity of the reinforced soil to the bearing capacity of the unreinforced one. And coming to results and discussions, a maximum bearing pressure of 361 kilopascal and a settlement of 40.87 was observed when unreinforced sandbed were modeled. The bearing, pressure versus settlement graph is also given. And with the increase in the number of layers, the applied pressure is distributed over more significant depth, thereby contributing to higher bearing capacity and settlement reduction. When the number of layers increases, the bearing capacity also increases. Beyond a certain depth, the inclusion of reinforcement has no significant effect in the bearing capacity. At 4 and 5, when the number of reinforcements are 4 and 5, the load settlement curves are almost same. Considering the economic aspects, the 3 layers of reinforcement are sufficient for the optimum performance. This is the load settlement curve as well as the improvement factor obtained for different percentages of settlement. As you can see that at number of reinforcement is 4 and 5, the curve is almost similar. These are the output, the contour, the settlement contour for we obtained from the Plaxis software. And this is a validation table which compares the experimental results and numerical ones. You can see that the numerical results were slightly less than that improvement factor obtained from the experimental study. But it is almost close, and a maximum percentage difference of 9.26 was observed. And coming to the conclusions, the bearing capacity of soil can be increased when reinforcement with bamboo grids of rectangular pattern. When the number of layers is more, the bearing capacity was also found to be more. There is no significant increase in bearing pressure from layer 4 to 5. So by considering the economic aspects, we can say that optimum results were obtained at 4 layers of reinforcement. These are the answers. Thank you.
Thank you, Ajis, for a nice presentation and sticking to your time. So let's move to the next speaker, Karishmita and Atanu Kumar. They will be speaking about nonlinear static pushover analysis of plain irregular structure incorporating soil structure interaction. Is Karishmita is there? Paper number 31. Kindly share your screen and then we start presenting. Karishmita, are you there? So I think we are not getting any signal from her. Maybe Mr. Rahul has come back. I think he has not given his number in this chat box. So his title is Numerical Analysis of Ring Foundation Fixed with GeoGrid. If Rahul is there, please kindly share your screen. Rahul? So try to conclude in 5 minutes.
Sir, am I audible?
Yes.
Okay. Sir, my topic of good evening, everyone. My topic of presentation is numerical analysis of ring foundation fixed with GeoGrid. So these are the content which I'm going to cover in this presentation. So for the structure like chimney, silos, transmission tower, the foundation is usually circular in plane, and these structures are tall structures. These structures, along with heavy vertical loads, are subjected to strong lateral loads due to winds. Because of this, the strong heavy overturning movement gets developed at the foundation of these structures. So I have
Slide
carried
share.
my yes sir. So I have carried my research to decrease effect of overturning moment on ring foundation by using GeoGrid as a reinforcement material. So GeoGrid is a geosynthetic material that is generally strong in tension. So these are some terminology related with the ring foundation. Ring foundation consists of two rings, that is inner ring and outer ring. The radius of inner ring is inner radius and the radius of outer ring is outer radius. And the ratio of inner
We are
radius...
unable to see your presentation. So only the front slide is there. I think it is frozen.
Sir, okay sir. One. Sir, is it working now? Excuse me, sir.
Yeah.
Okay, sir. So
Go to slideshow. Go to slideshow and then.
Sir, I am in slideshow only. Is it working?
No, it's not working.
Sir, is it
Go to the
working?
next slide.
One sir. Sir, is it working?
No. I think there is another problem, I think, with Karishmita also.
Okay, sir.
Professor Ghosh, so can we take this two presentation to tomorrow? Keep mind.
Sir, is it working now?
Yeah. Yes, quickly present.
Okay, sir. So the ratio of inner radius to outer radius of ring foundation is known as ring radii ratio, and it is also it is n value. And the radius that divides the ring surface into two equal areas is central radius. This is how ring foundation looks, and this is how I attach geogrid with the circumference of ring foundation, and other end of geogrid is kept fixed. So this is the objective of my study, is to verify the load carrying capacity and overturning moment resistance capacity by fixing geogrid with ring foundation. And second objective is to optimize the size of ring foundation by fixing geogrid. And third objective is to find the effect of n value, number of columns and subgrid direction and central radius on the behavior of ring foundation. So for this, I have done analysis using finite element method. I used ANSYS software for this, and before proceeding, I have validated a finite difference method solution given by Winterkorn and Fang in 1970, and validated it using ANSYS software. So these are the steps followed in ANSYS. First, we have to define material, then create geometry, then assigning contacts and meshing, then loading and boundary conditions are assigned, then analysis is performed, and we get the result. So these are the material properties that have been used. Total 3 materials are defined, that is concrete, cohesionless sand, and geogrid. These are the properties of the materials, and these are the dimensions of ring model, geogrid, and soil that I used. This is the ring foundation resting on a cohesionless soil, and this is the ring foundation attached with geogrid at 45 degree resting on a cohesionless soil. There is one more case, that is ring foundation attached with geogrid at 90 degrees, in which 4 strips of geogrid is used. So let's see the result. This is the load versus settlement curve to know the effect of geogrid, and the blue line shows the settlement behavior of ring foundation without geogrid. Red line shows the settlement of ring foundation with geogrid attached at 90 degrees, and the green line shows the settlement of ring foundation with geogrid attached at 45 degrees. So from this, we can say that the load carrying capacity of ring foundation fixed with geogrid is more as compared to ring foundation without geogrid, and as the amount of geogrid is increased, the load carrying capacity also increases. This graph is showing the overturning moment versus settlement behavior of ring foundation. Here, blue line resemblance the overturning moment resistant behavior of ring without geogrid, and red resemblance the overturning moment resistance capacity behavior of of ring foundation with geogrid attached at 90 degrees, and the green line indicates the behavior of ring foundation fixed with geogrid at 45 degrees. From this graph, we can say that the overturning moment resistance is more when geogrid is attached to the ring foundation, and as the geogrid is increased, the overturning moment resistance capacity also increases. In this case, I have compared the large diameter ring foundation with the small diameter ring foundation fixed with geogrid, and I have found that the load carrying capacity of small diameter ring foundation fixed with geogrid is more as compared to large diameter ring foundation. In this, here I found that the small diameter ring foundation fixed with geogrid is giving better overturning moment resistance as compared to large diameter ring foundation. And from this, we can say that from these two graphs, we can optimize the size of ring foundation. We can conclude that this is the effect of this is settlement load settlement effect This is the effect of n value. This graph shows the effect of n value on load settlement behavior. And from this graph, we can conclude that as the n value increases, the load carrying capacity of ring foundation decreases. And this graph shows the effect of n value on overturning moment resistance capacity. From this, we can say that as the n value increases, the overturning moment resistance capacity decreases. This graph shows the effect of subgrade reaction on the settlement behavior of ring foundation. As the subgrade reaction increases, the settlement decreases. This graph shows the effect of number of loaded columns on the settlement behavior of ring foundation. As the number of columns increase from 4 to 10, the settlement decreases and moves towards the uniformity. This shows the effect of central radius on the settlement behavior of ring foundation. As the central radius increases, the settlement decreases. And at last, these are the conclusion. The geogrid, it is found that the geogrid has a substantial effect on settlement behavior and overturning moment resistance capacity of ring foundation. And it is found that the load carrying capacity and overturning moment resistance capacity is increased by fixing geogrid. And as the amount of geogrid is increased, the load carrying capacity and overturning moment resistance capacity is also increased. It is also found that when the 300 mm ring foundation fixed to geogrid gives better result in load carrying capacity and overturning moment resistance capacity as compared to 400 mm ring foundation. In this way, the ring foundation size can be optimized and the material can be saved. As n value increases, the load carrying capacity along with overturning moment resistance capacity decreases. And as the subgrade reaction of the soil increases, the settlement of ring foundation decreases. And as the number of loaded columns are increased, the settlement decreases and leads towards uniformity. And the final conclusion is that as the central radius increases, keeping load constant, the settlement of ring foundation decreases. So these are the references. Thank you.
Thank you, Rahul, for a good presentation. And it's a very interesting study you have showed us.
Thank you, sir.
So, only one speaker is left, and Karishmita, she was unable to present today. So maybe if you are available, you can present it in the next session. That is team number 9. Tomorrow also you will be having a chance for you to present. So over to Professor Ghosh, sir.
Okay. I was virtually present, but Professor Vishwanathan, please. You are really present. Please give.
This is virtually real, really virtual. So
please, you please whatever concluding remarks.
Yeah, I think I could see the persistent patience of Dr. Rajesh. So he patiently conducted, and the session I really appreciate. And I think
Professor BVS, I can tell you why he is like this, because you are in front of him, so now he cannot escape anywhere. He accept goes up. Yeah.
And I think we have, out of the, Rajesh, how many papers were presented?
12 paper has been presented.
Largest number I have seen.
Largest number. When Reddy has contacted me, can you do the session coordination? Means I agreed, but I was not knowing that it actually has got sessions.
Good that Rajesh is given to you.
Yeah. So I think 12 papers are presented, but I noticed one suggestion I wanted to give, if they accept in a proper listing. I've seen some presenters actually using abstract and many words and all. with these, if they are presenting in mobile and all those things and all, it is not advisable to present in so many words. They should limit lot of words in the slide actually. And this was actually told to me by my teacher. Where I made same mistake and then it has been told at that time. So I think I'm passing on that to maybe to Vikas Patil and I think I have seen some people they have used like that. So one thing I noticed is that many institutes are having now the patches 3D, 2D or softwares. I think the better usage of these softwares will lead to some understanding about and modeling about these type of analysis and all. And one thing what I understand is that from our side, today only we received one email that the next semester also will be in the online. Then how to do projects online, projects online, which is very difficult. So this means that this type of packages will be helpful in executing some work if they have to do this project. And I think I appreciate we started with some 31 members, 56 members went, and it came down to 20, including all three of us. I really appreciate chairman and co-chairman. So on behalf of the organizers, I thank Professor Chandan for his virtual presence. In fact, if Professor Chandan Ghosh should have come, then we would have gone for a culture program and had a nice lifting and all on the beach and all. But now we can't beach.
Yeah.
That is, yeah. In Kashmir, you will not get the beach.
Yeah.
Same with Rajesh also. Maybe he can go to river and relax, but no beach. But I think I really appreciate. And Rajesh, I think tomorrow we are still having our responsibility to complete and keep doing our work. And I'm seeing Nasaka is actually present. And so I thank all the delegates, chairman and co-chairman for their presence in this session. And we'll be again meeting. And maybe at the end we'll give the complete, though the chairman will change, but we'll give the complete this thing, because we have to recommend some 2 best papers in this team. So maybe we'll discuss among ourselves. At that time, I request Professor Chandan Ghosh to come online. Sure. We can discuss. Okay.
When tomorrow, anytime?
Tomorrow, 11:30. After the session, maybe around 1:30. I will contact you through WhatsApp or telephone.
Okay, sure.
Okay. Thank you, Professor Nasaka. Thank you, Dr. Rajesh. Thank you, Professor Chandan Ghosh. Thank you.
Thank you.
Keep doing well and keep doing well and keep safe.
Yeah, so better Rajesh don't come to office. We could see, so Rajesh is in office. And of course, this previous also in office, I could see him. No, but to be on lighter side, better to be in the office if you really want to protect yourself from home ministry. If you want to protect yourself from home ministry and other consequences, better to be in office. Whatever you want to do, all are accepted. Here, every moment they come and see.
It is live.